Good morning to all. Welcome to the second day of International Conference. St. Margaret's Engineering College and the Department of Mechanical Engineering is delighted to welcome you to the CSIR-funded hybrid conference on sustainable materials and advances in renewable technologies, SMART 22. The conference brings together academia, researchers, industry experts, and scientists who are responsible for delivering sustainable and eco-friendly solutions. I welcome the presentees and participants for the international conference. I would like to introduce the keynote speaker of the day, Mr. Sanjay Jairaj, Project Manager, Vehicle Interior Safety Systems, Engineering Research Center, Tata Motors. Graduated in Mechanical Engineering from Sardar Raja College, he holds a master's degree in Manufacturing Management from BITS Pilani. He also holds the Cambridge University certification of professional achievement in circular economy and sustainability strategies. His achievements include Award for Contribution towards Tego and Tiger Lunch, Award for the contribution towards product quality improvement, and also for his contribution towards development of new Safari. His key role in Tata Motors include product development, designing core strategies, leading projects with India's largest OEM. We are indeed to have you with us, sir. Happy to have you with us, sir.
You, me, industry experts, everyone, individual, everyone has a role to play. And the project is really crucial for the humanity to survive. And the subject of sustainability is not limited to any particular industry or a sector. If you and me are part of the century, so definitely we have a role to play towards sustainability initiatives. In the upcoming slides, I will share few of my perspectives. I hope you will find it interesting and useful. Making sense of sustainability. So it is really important to understand this concept of sustainability in its very basic form. And I always have this habit of understanding any concept in its very basic form, in the order of why, how, and what. So why always remains the fuzziest thing. So if we are able to understand the why part of any concept, its basic form, the how part and the what part becomes much easier. So why sustainability? Why we are talking about sustainability so much? why we are concerned about this subject. Recently, we celebrated Earth Day, and it is very common to hear this slogan, save this planet, save Earth. But the one immediate question which comes to my mind, does this planet need saving? This planet is at least 4 billion years old. It has gone through a lot of destructions. It has gone through a lot of changes. And definitely it can survive on its own. So, does it really need a saving campaign? So, what sustainability has to do with saving this planet? If you really have a close look on the initiatives, sustainability initiatives, and the issues which we are facing at this point of time, it is all related to us. It is related to survival of our human species. It is about the compatibility of this planet with our human species. We are thinking about whether this planet is going to remain compatible in the upcoming future, in the next 100, 200 years, for our survival. So it's not about saving this planet. It's about saving ourselves. So why I'm emphasizing much on this particular aspect? It is important to register this message that when it comes to sustainability initiatives, everyone has a role to play. Sustainability is not about industries alone. It is not limited to industries. It is not limited to any sector. It is about each and every individual, and everyone has a role to play. It is about the way of life we are going to have, which is going to determine the sustainability of this planet so that it remains compatible. The next important thing which we need to understand when we talk about sustainability is the Paris Agreement. The Paris Agreement says, it talks about limiting the temperature rise below 2 degrees C and pursue efforts to limit the temperature increase even further to 1.5 degrees C above the industrial levels. So why is it so important? As per the research done so far, it estimates the 2 degrees Celsius rise in temperature levels is going to have a huge impact on our species, on the planet. It is going to lead to increase in sea levels, and it is estimated that 33% of the population will get impacted because of sea level rise increase. So it is important to understand the impact of the increase in temperature levels. It is going to, according to research, the 2 degrees C rise is going to lead to food scarcity, unpredictable seasonal changes, and it is going to lead to extinction of many other species. And to From the sustainability perspective, the Paris Agreement is one critical initiative and an aspect. The other side of the Paris Agreement, if I look at Paris Agreement, the other side of the coin, we are talking about the regulations, the policies which are going to come in. Because of the Paris Agreement, the agreement which our government, the Indian government, and so the policies, the regulations which are going to come in is every sustainability initiatives is also, and one important aspect, the Paris Agreement. It can be seen as an implication of Paris Agreement. And it is closely associated with the sustainability initiatives at a macro level. Next thing which we need to think about is the renewable energy. And it is really important to understand the renewable energy and innovations on this particular space can prevent only 55% of GHG emissions, greenhouse gas emissions. The remaining 45% of the GHG emissions are to be managed through sustainability initiatives. So it is very clear that renewable energy alone cannot solve the current climate crisis. In this slide, we are not going to talk about the economics associated with sustainability. Whenever we talk about economics, we are talking about something scarce, which is limited, which is rare. We are talking about the materials, the resources which are scarce, and how it has to be dealt. The subject of economics is always associated with scarcity. So, we all have been experiencing increase in commodity prices, right? So, if technology is the answer, is a solution for all our problems, it could have very well prevented this increase in commodity prices, right? So, it is very clear. Technology alone cannot solve the current crisis. Technology can be one of the enablers of sustainability, but cannot be a standalone solution. So as the resources are becoming scarce, we are talking about natural resources here. The technology cannot produce natural resources. Since the technology cannot produce natural resources, the commodity prices are increasing. So it is important to understand the relationship between resources and the commodity prices. And we need to think about this concept, whether this is sustainable. If you continue practicing the present form of living, or the processes which we follow, the life which we are having, the businesses which we are having, is it sustainable? The next important thing is the demand and supply. So when it comes to the businesses, the economics, it is about demand and supply. So here we are talking about sustainability, associated demand and supply. The demand, which is created by the customer or the end user, is met by the industries in the form of supplies. So it is important to understand the demand which is getting created is for sustainable products or not. It's important to understand the demand, whatever demand is being created, it is created by the customers. It is about us people who are creating this demand. And the supply is made accordingly. So the demand and supply and are closely associated with the sustainability aspect. The next important thing is well-being. It is very well demonstrated in recent times. The COVID crisis has very well demonstrated that without well-being, there is no economy. When we talk about well-being, we are talking about the holistic well-being of societies, the places where they live, the conditions which they operate. The health conditions of the communities. So, it is very clear when it comes to sustainability, from the sustainability perspective of the economy. The economy cannot thrive without well-being of the society. So, well-being of people and the society is one crucial aspect of sustainability. The next one, we are talking about money. So it is really important to understand the role of money in terms of sustainability. We need to realize, or we need to understand that the development we had so far in terms of technology, in terms of health services, in terms of our own well-being, in terms of life expectancy, the successes we had so far, it has close connections with the economy, the prosperity which we had, and the driving factor, which is the money. So, one cannot look at sustainability and the economics part of it without considering the financial aspect of the economy, of the sustainability. So money is one important tool to enable sustainability. So whatever sustainability initiatives we take, when it comes to the companies or organizations, it is important we create money. Otherwise, the model itself becomes unsustainable. In the upcoming slides, I'll take you through the models, the sustainable models, which will make you understand this concept in a much better fashion. So what is the way forward? Sustainable industries and sustainable individuals, right? So when we are talking about sustainable industries, we are talking about totally different approach. We are talking about industries which are self-sufficient, which extract less natural resources or no natural resources. And when we are talking about sustainable individuals, we expect the same. We talk about their individual decisions, where we are talking about their demands, we are talking about their actions. So let's have an industry perspective on sustainability. So the current model which we have, which is a linear model, which is based on the concept of extract, make, dispose. So here we are talking about extracting natural resources, making products, using it, and just simply disposing it. So here we are not talking about here we are just talking about extracting the natural resources as if it is infinitely available, making products and disposing it. So since we, in the last few slides, we spoke about the scarcity of natural resources, it is important that we have a model which is sustainable. The current model which we are looking at is, it is very well proven now that it is unsustainable. We have, the last few slides, we have spoke about increasing commodity prices, the current climate crisis. So all that points to this model, which is operating this way of extracting resources, natural resources, making products, and disposing it without any concern about environment, people, or the impact of those disposed products. Here on the right side, we do have a sustainable model. We can call it as a circular model. So this circular model which we are looking at is on the basis, on the concept of defining out waste. So we are saying there will be no waste. We won't be producing any waste out of whatever options we have in our businesses, in our lives. We're not going to produce any waste. So whatever waste which we are talking about, which we consider as an like output of the operations, is going to be enablers of sustainability. So why is it so? It is important to understand that whatever we could trace and measure, and wherever we could generate data, if we are not able to generate data, it is difficult to actually trace. So from the sustainability point of view, when we are talking about increasing efficiencies in the system, here if you're talking about operations, it is all about increasing the efficiencies. So when it comes to the recycling of the or remanufacturing of any part, material repurposing it, it is important to understand the traceability part of it. So that's where the technology plays a major role. Here we are talking about IoT, Internet of Things, machine learning, and blockchain technology. So when we are talking about IoT, we are talking about sensors here.
Thank you, Sanjay sir, for sharing your ideas on sustainability. We are indeed that you joined us as a speaker. Looking forward to more such engagements, sir. Thank you so much. Next, we have Deepika online to present. Ms. Deepika, Deepika from Mahalingam College of Engineering. Deepika M.
Yes, ma'am.
Yeah, Deepika M, you can share your screen, ma.
Hello, ma'am. Can you hear me?
Your voice.
Ma'am,
Deepika, you can
ma'am, can
share
you
your
hear me?
screen.
Yes, I'm here, ma'am.
Your voice is audible,
Excuse
your screen is not visible.
ma'am, give me a second. Ma'am, give me a second.
Yeah, okay. Deepika, you have 15 minutes time, ma. Make sure you.
Oh, okay, ma'am. Give me a second. I could not able to share my this presentation.
Deepika, have you resolved it?
Ma'am, I'm here. Yeah, give me a second, ma'am. 2 minutes, ma'am. Is it visible, ma'am? Ma'am, is
Yeah,
it
Deepika,
visible?
your screen is visible. Yeah, yes, Deepika, your screen is visible. Deepika, you can
Okay.
directly go to your, you need not present your literature survey and all, you can directly go to your work now. Okay? So you
Okay, ma'am.
have
Sure.
6 to 7 minutes to present and it will be 3 minutes of question session. Okay?
Okay, ma'am. Sure.
Okay.
Good morning
Thank
to
you.
one. Okay. Good morning to one and all present here. My name is Deepika. I'm pursuing ME in Dr. Mahalingam College of Engineering and Technology. I'm going to present a paper on performance of various K-opt-based cluster formation in wireless sensor network. Objective of our presentation was to enhance the network lifetime of the wireless sensor network by adopting the optimal cluster formation. So, what is a wireless sensor network? Normally, the Internet of Things consists of nowadays the Internet of Things consists of Internet of Things refers to a billions of smart devices which are connected around the world, which will share the information through the internet. So this is a rapid emerging domain in the field of homes, cities, environment, healthcare, and agriculture. There are various Internet of Things devices like heart monitoring implants, biochip transponders, and Alexa, etc. So in order to implement the Internet of Device, there are many major complements. What we need to deploy the Internet of Things is that the wireless sensor network. This is a diplomatic diagram of the large-scale IoT. Main equipments which needed to implement the Internet of Things is a wireless sensor network and a server, internet, and application and base station. So our main aim of this project is to enhance the lifetime of this sensor. Actually, sensors are battery operated. So in order to normally we are going to deploy in the sensors in the random environment, that is a remote environment. So it is important, it is impossible to recharge the battery of the wireless sensor network. So our main aim of this project to enhance the network lifetime of the wireless sensor network. So here we have adopted the optimal cluster formation. uh, what we have done is we have taken the MATLAB 2018 as a simulation platform, and we have considered the random number of nodes. For example, we have considered the 100 number of nodes, and we have whatever nodes we have taken as a static and homogeneous, which has a same amount of energy, and we have fixed the base station at the center of the network. The base station will collect all the information from the sensor node. This base station may be either battery operated or operated by the power supply. And we have taken the two parameters here. One is a dead node. Dead node are the sensor node whose battery energy level is lower than the energy level required for sensing. Alive nodes are the nodes which has the energy required for sensing and processing. These are the parameters which we have taken in a MATLAB. That is, we have taken the network size of 100 to 100 cross network. We have placed the base station at the center of the network. Number of sensor node we have considered here is 100. And the initial energy for all the sensor nodes, since it's the homogeneous, it is a 0.5 joules. So after deploying this, our network in this MATLAB, our network will look like this. These are the circle, whichever shows here is the nodes, and the center thing is a cluster head, and the base station is placed at the center of the network. And we have taken the first order radio model as our model to calculate the energy consumption when each node started to communicate the processing. These are the equations which we are using for calculating the energy during the transmission and the reception. So first, what we have done is we have done a direct transmission. That is, we have made each and every sensor node to collect the data, and we asked the each and we made each and every sensor node to transfer the data directly to the base station. When we have done this, we have found a drawback like direct transmission requires a large amount of transmitting power because each node, irrespective of its position, will have to transfer the entire amount of information which it gathered to the base station. So it will drain the battery of the nodes, which will reduce the system lifetime. So in order to overcome this drawback of the direct transmission, we have come up with another protocol called as a hierarchical protocol called LEACH. This is a low energy adaptive clustering protocol. In this protocol, instead of each node transferring the information to the base station, the nodes are formed into cluster called groups, and among the clusters, only one member is selected as a cluster head, and that particular cluster head will collect the information from the other nodes, will send the data to the base station. So, and we have compared the lifetime of this LEACH protocol and the direct transmission and found a better lifetime in LEACH compared to that of direct transmission protocol. So again in LEACH protocol, we found the drawback like election of cluster head is done randomly in a LEACH protocol. So the probability of the nodes which have the lesser energy has a probability to be elected as a cluster head. So this is the main drawback which we found in the LEACH protocol. So in order to overcome this LEACH protocol, we have done a modification in the classical LEACH algorithm by considering the important parameters like initial energy and the remaining energy of the individual nodes. So on each round, while selecting the cluster head, we'll check the residual energy of the non-cluster nodes. The nodes which have the much more energy compared to that of other nodes will be elected as the cluster head. And we have compared the lifetime of this R leach with the this is the modification we have done in a leach protocol and R leach protocol, and we have considered this important parameters, that is E residual and E initial. So in our leach protocols also we have seen the better lifetime, but there is also certain drawback in this R leach protocol. That is, the random cluster formation is done in both leach and R leach protocol. So the cluster head bears some extra load other than the sensing and communication when we deploy a random cluster formation. So this important improper cluster formation lead to the cluster overhead. In order to overcome this, what we are trying to do is we will do the optimum cluster formation. That is, instead of randomly forming the clusters, we will place the optimal cluster formation by considering the certain amount of numbers. So for forming the optimum cluster formation, we have considered the three equations we have considered for the optimal cluster formation. These are the three equations, and we have checked the lifetime of this each equation. When we compare the lifetime of this K1, K2, K3, we found that K2 provides a better lifetime. That is, when we deploy the optimal cluster formation, with this three equation, the equation 2 provides a better lifetime compared to that of other protocol. This is a comparison of lifetime. That is, number of nodes which were which at the end of the processing, how much number of nodes remain alive for further communication. We have checked the dead node count. That is, at each and every node, how many number of nodes losses the energy. We have found that in direct transmission, leach K1 and K2. So we have found that K1 and K3 provide.
Thank you for your presentation. Go to conclusion.
Okay. So the summary says that K1 and K3 outperformed well compared to that of K2. So the optimal cluster formation provide a better lifetime compared to that of dynamic cluster formation. This network lifetime can be further improved using load balancing cluster formation and node placement technique. Thank you. So done with my presentation.
Any questions from audience? Okay, what is your objective?
Our objective was to enhance the lifetime of the sensors which we are presenting in our that is, we are going to save energy of the sensor nodes for enhancing the battery life.
Okay, thank you. Thank you for your nice presentation. Thank you.
Thank you, sir.
Good morning, ma'am. Next we have Dr. Nafina, keynote speaker. Ma'am?
Yeah, ma'am. Am I audible?
Yeah, yes, ma'am. Yes, ma'am. I'm very happy to introduce Dr. Nafina. Dr. Nafina has completed her bachelor degree in the branch of Tripoli from PSNA College of Engineering and Technology. She holds a master degree in electrical and electronics engineering from Crescent Engineering College. She has completed her PhD in Nana University in the area Smart Grid. Dr. Nafina has more than 15 years of teaching experience in various colleges and universities, and currently she's working as professor in Villa College, Maldives. She has published many papers in Scopus, Web of Science, and Science Index and UGC Journal. She's also a reviewer in reputed international and national journals. She has given many keynote lectures in reputed colleges and universities in the area of patent filing and intellectual property rights. Presently, she's doing consultation to leading tourism industries in Maldives. Apart from that, she has received many awards and recognitions and credentials from the government of Maldives for her exemplary work in the area of IPR-related activities. She has a keen interest in interacting and educating the younger minds to get a better prosperous in life. Ma'am, the platform is yours, ma'am.
Thank you so much. Thank you for your nice introduction about me. I'm so happy to give a keynote for this session. And then I appreciate the team for selecting this topic, sustainable materials and renewable energy technologies, which is a very, very important one at this stage, but we have to discuss, right? Okay, I'm sharing my screen. Is my screen visible?
Yes, ma'am. Yes, ma'am. Your screen is visible.
Yeah. May I start?
Yeah, yes, ma'am. Yes, ma'am. You can start.
Okay. So I have selected a topic on life cycle analysis. So we will see what is the life cycle analysis later. Before that, you all know, well, I think as she introduced me, I am Dr. Nafina Abdul Munaf. I am assistant professor in Faculty of Engineering Technology in Villa College in Maldives. Okay. So before going to my topic, first of all, I want to address sustainability. This is very, very essential one. So we all know the definition, the common definition, that is sustainability is the development that meets the needs of the present without compromising the ability of the future generations to meet their own needs. So this is given by this World Commission of Environmental Development. So when we are talking about sustainability, so everywhere now it is happening like sustainable. So what is sustainability? So we should be very clear about the objective of all these conferences or everything happening. So because we are in the age of so many environmental crises. So like so many things now, climate changes, everything happening is due to the improper knowledge of sustainability. So we as engineers, we as a technical person, we should be very clear about the sustainability. So we are serving the anything. For example, if you are doing a process or product, anything. So you should be have to meet the three main things. One is economy, and another one is environment, another one is society. We will say it is a triple bottom layer of success. So when you are able to that is attain these three objectives in any aspect, we can say. In your, for example, if you are doing a project, or even if I finally a project, or even if you are doing any, if you are producing any product in your future when you are working. So any project you are designing, planning, you are considering these three aspects, then no need to talk much about sustainability. Sustainability will be always achieved from this. So economy, environment, and society. So economy in the sense, so we will just talk about the profit, right? So environment in the sense planet. So our planet, we have to conserve our planet. Even when we are seeing the profit, we have to think about the planet also. Society is us, people. So when you are able to consider these people, planet, and profit, all these three things, you can say we are in a sustainable world. So sustainable electrical energy, we all know. So we are mostly dependent on fossil fuel energy. So which is the main drawback which causes so many problems for climate change. So what are the importance of electrical energy? You have to select which is on an environmental base, and then that energy also should be used for future generations, not only you are considering now. So whatever using your energy using, whether now we are using coal for producing electricity, if you are using coal in thermal plant, when the coal is getting depleted, so once it is over, for future generation, whether it will be useful? No. So it is not a sustainable electrical energy. So then what is sustainable electrical? Whether we have a energy security in producing our energy. So that also is very important. We are going for nuclear power plant. There are so many harmful effects are there. So when we are thinking about only the outcome, when we are not considering, as I said, the planet and then the people around us, then it's going to be a security problem. So when you are considering all these things, we can say we are producing sustainable electrical energy, right? So we all know renewable energy is a green energy. It comes from natural resources. So we no need to depend on any available resource that is going on depletion like nuclear fuels. If we are using it one stage, it will be over. We cannot rely on that for the future generations. But the natural resources, we can always depend upon the natural resources at any time. At present or for the future, it will be available. Sunlight, wind, rain, tides, geothermal, everything, right? So we all know these are the very basic things. I don't want to give much about this. We all know what is pure fossil fuel energy also. So energy produced from oil, natural gas, coal. So if we are producing energy using these things, we are saying it as a natural energy, fossil fuel energy, sorry. So what this chart says. So according to this chart, we can see, so there are fossil fuels. So you can see here, no? So we are depending on 62.8% on fossil fuels, just 10.4% on nuclear. So see this. So we are talking about always renewable energy, but we are very, very lagging in the production of renewable energy, just 23.6%. We are depending upon the hydro, wind, and solar. So then now we are doing so many researches on hybrid solar and wind hybrid, and so many experiments are so many things, the researches are going on, but still we are not in a good, we have not achieved the proper percentage of production of solar, that is our renewable energy resources. So in that we can see oil, coal is the 36.4%. We are depending upon the coal for production of energy. So these are going to, why we are not using others, fossil fuel energy, we are saying why the 62% of we are using, it's not going to be a good thing. And then why we have to improve this? So because the fossil fuel energy is going to produce so many, so we are having so many type of environmental issues like we can say climate change, sea level rise, or so many things like global warming, everything happening due to what? The carbon emission. So carbon emission is going to be a worst thing, which is mainly due to the fossil fuel energy, right? So the Kyoto Protocol has defined some gases as a greenhouse gases. So carbon dioxide, methane, all those things are considered as greenhouse gases. Mainly it is produced from our fossil fuel energy. So we not only in power production places, we are using for transportation. So in so many places we are using, wherever you are using this oil, we are going to produce some carbon emissions to the environment. right? So it is going to affect what? See, what is the thing you are going to see or seeing here? So you can see global atmospheric concentration of greenhouse gases. So how it is increased? You can see this has taken from 2005 as reference. This is 2005. Okay. And then this is before 5,000 and 10,000. Yes. Up 2005. So you can see the graph. See, this is carbon dioxide parts per minute taken in y-axis. So there are two graphs. One is radioactive posing. So when you are using the fossil fuel energy, it's not more than for 5,000 years. We are not dependent upon only the thermal energy, right? So when the oil usage is when it is getting increased, so you can see the increase of carbon dioxide emission here. So we can see a very steep increase of carbon dioxide emission. So this is a very worst scenario, and then we can see the radioactive forcing due to this carbon dioxide emission. So not only for this, I'm talking about carbon dioxide, so methane, nitrous oxide, we are using so many detergent products in our home, also producing this kind of greenhouse gases. So it is going to affect the environment. So as per survey, so this is the world ecological footprint by land type. So we can divide the land as different lands like fishing grounds, cropland, build-up land, forest products, grazing land. So you can see different colors, right? So fishing ground, so this is a fishing ground, and this is cropland, and this is going to be a build-up land, forest products, grazing lands. So in this graph, you can see, so which one is very highest area, which covers a very highest area is carbon. So we are living in a world with so much of different kind of land. So we all will think we are this world will have a different kind of land we are living here. But we are living in a carbon emitted land, carbon emitted world. So this is taken in global hectares. So what will happen if this is going on increasing like this? So who is going to monitor this? So what is an individual, our responsibility to monitor this or to reduce this? That is very, very important aspect we have to think, because so nowadays you can see so many changes in the environment, so many changes in the climate. So climate change is taken as a very important focus. Even we have to meet the sustainable goals. There are some sustainable goals developed by the United Nations. So we have to always depend upon that. We have to check about that for every aspect when you are thinking it. So otherwise this carbon footprint is going to be increasing, and it's going, finally we are going to be affected. Our generations, our future generations going to be we are going to give a very worst scenario to our future generation. That only we can say. So what happens if the carbon footprint is getting increased? So this is the temperature rise. So you can see year-wise, it is taken the temperature rise. So it is going on increasing. So 0.4 degrees centigrade, it is increasing. So every time, okay. So what is going to be the thing you are going to do? What is your own contribution for everything? Everything is depend on our hand also. We cannot always say others, someone doing research or someone doing working in this organizations are going to do something. So it is in our hand to think about all these measures. So this you can see sea level rise. So what is a sea level rise? See, there are so many people living in a coastal region. If sea level rise is due to the carbon emission like this, okay, so what happened? So the land level will reduce, the sea level will get increased. So there won't be people in the coastal regions living. So we are only thinking about other living things, right? So in planet, we are not only human being here, so many organisms. Previously, we will think about other organisms in the planet will be affected. So these things will happen. Even our human life also is going to be affected if the sea level is going to rise like this. So till 2000 only I have given this figure. So think about now in 22, how much level rise it will be there. Then how the people near in the sea level, coastal regions going to live, like Maldives or Japan or so many places. And then change in volume of glaciers. So it is given the volume, and then for different regions, North America Arctic region, Russian Arctic region, Eurasian Arctic region, and all Arctic regions, how the volume of glaciers are given as a graphically it is shown. So when the year by year it is increasing, the volume of glacier is getting reduced. So water level is getting high. So the living things in that particular area is also going to be vanishing one, right? So there are so many coastal region places, are there, island countries like Cook Islands, Fiji, and then we all know Japan, Maldives, Tonga, Tuvalu, for so many places. So it is given in millimeters, how much sea level rise is there per year. You can see per year how much it is rise. Per year, you can see the highest is 2.3 millimeters. So we are seeing, we are facing so many problems like tsunami, everything. So whether we have, so we forget everything, right? Tsunami, those things happen once if we forget. So what will happen if the sea level rise happen? So every year you are going to have a tsunami like things. So the people around the coastal region will be affected due to the sea level rise. So what is the main cause of these things? Everything is due to our fossil fuel, energy, and then the knowledge, lack of knowledge in the sustainability. So when you are not considering our people, planet, profit, then finally what happened? So finally everything we are facing like sea level rise, like what we have seen. So heat, loss of the capacity to work due to heat. So heat increasing, global warming. So more wars to gain access to limited resources. So we are seeing the next world war is going to be for water crisis. Fresh water will be in short supply in some areas. The cost of adapting coastal areas to rising sea levels. So people in coastal regions will have to see another location for their life if this sea level is rises there. But the population growth and then the shortage of our land, so how they will be accommodated? Relocation of whole towns, shrinking productivity of harvest, prices of basic foodstuffs and consumer goods will rise. So what will happen? The climate change is going on, increasing. Extreme meteorological phenomena will cause widespread poverty. Diseases will spread due to high temperatures. So the sea level rise, temperature rise, these things may happen. So that may lead to limited resources, natural resources, and then finally there may be a war, or there may be so many diseases, or we may be suffering from the lack of foodstuffs, like so many things may happen. So what we can do to avoid these at the least level? So at the generation of any product, when you are using fossil fuel itself, we have to consider that. But if we are not still considered, because we cannot stop the things which is happening now. So at the earliest, what we can do? So the plants are considered as carbon stock. So we can grow so many plants. So it will consume the carbon dioxide. So the carbon footprint may get reduced if you are going for more plants. But what we are doing, we are going for deforestation. When the villages are going to be occupied with city, the people, those who are going to occupy in the places like where the the agricultural fields are getting into land. So population growth is more. So again, we are going for deforestation. So then how this carbon dioxide is going to be reduced? So we have to think about in every aspect that we have to depend upon the plants for our safety. So other things what we can do to reduce your carbon footprint. So everyone will have a carbon footprint. If you do a survey for yourself for per year, how much carbon you are consuming, how you are emitting. So you are using transportation. So in a home, there are 4 people will be there. So everyone will have their own transport. So the even crossing the same destination, now we have enough economy to buy everything, right? So more than two-wheelers or one car will be there. Okay, so better we can choose a public transport in that cases to reduce our carbon footprint. And then we are not conserving our energy, which is produced through fossil fuel. So energy usage is more means fossil fuel usage, carbon emissions will also be going to be more. So promote plant life, buy a fuel efficient vehicle. So when you are thinking about a fuel efficient vehicle also, when we are saying now it is electric car everywhere. So we have to think in every aspect. That's what I have taken a topic as a life cycle analysis. I will come to that one, how we have to do that. So whether that electric car also it's a sustainable one, we have to think in that. So when we are doing a survey, when we have done a survey recently, electric car is not a sustainable one since it is using a battery like cobalt like thing was used for production of battery, which is digged from the mines using child labor. So now saying that electric cars electric vehicles are also not sustainable. So which is a fuel efficient vehicle, which is a sustainable vehicle, we have to think. Locally grown food, reduce electricity use, reduce your traveling, try to walk some distance for a nearby shop when you are going to buy something. So better you can walk, avoid using your vehicles, transportation can be reduced, and then your health also will be increased. Your life also will be very good if you are doing exercise like walking things. Take less trips, air trips, reduce, reuse, recycle. This is a very important aspect we can think in every aspect. Then what is the important role of our life cycle analysis to reduce your carbon footprint? It's a very important tool. It's a very simple thing only. What is it? Life cycle analysis is a technique which is used to analyze the environmental impacts which are an outcome of the process involved in the life cycle analysis of a product. So we are having so many products, we are using so many products, whether we are thinking from the manufacturing till the end of the life, the product is not harmful to the environment. Whether we are thinking in that aspect, we are using so many mobile phone. Once the market is introducing a new phone, we are throwing our old phone. What happened to it? Are you thinking about it as engineers? Are we having a knowledge about the environmental impact of the cell phone which you have thrown? So it is going to be a garbage. It's going to be electronic waste. And then finally, it is going to affect you only. You in the sense as everyone. So what we can do? We can think in different manner. We have to think as a life cycle thinking, we have to think. So cradle to grave assessment we have to do for any aspect. So why we are doing for quality improvement, quantifying, assessing the environmental implications and policies, achieving sustainability. For example, if you are going to, we all are using laptop. So now in this pandemic, the usage of laptop is getting increased. So everyone have laptop. So when we are thinking about life cycle analysis of a laptop, how we have to do it? Not only for laptop. So any product, you can think in this way. First, we are going to extract the raw material for developing the product, for producing the product. So then we are in a manufacturing process, and then we are going to package it. So once you have done, you are going to use it till disposable, till dispose, you are using the product and the end of life. So till this, we are thinking on every stages we are doing from the manufacturer, from the packaging, from the usage. So we have stopped here, right? So after this, there are 2 stages, end of life and recycling. Okay. So how a product can, what is the end of life of a product? You have to think in the manner while you are manufacturing a product. So that product will be certified with a cradle to grave certification. So this is the one I said, no? Cradle to grave certification will be given for the product. Okay. So we are using now everywhere, we are saying 3-star, 4-star ACs. So power consumption, what is it? Sustainable car, sustainable refrigerator. Likewise, now people are using only for marketing, but what happens? Is there the proper certification given for a sustainable product, cradle to grave certification? We have to check. We should have the knowledge. When they are saying this is a sustainable one, check whether you have a cradle to grave certificate for the particular product, even for a mobile phone. So after this usage, what is the end of life of the product? So when you're going to throw it, what happens? What happened to the battery of a laptop? What happened to the metals used in the manufacturing of the laptop? How it is going to harm the environment? When you are studying this, and then when you are able to recycle it, and then when you are using to again for manufacturing the product, so it's not going to harmful to environment, right? So everything we can think in the life cycle aspect. So this is a life cycle analysis, a very simple way we can do. So we can do a simple research. There are so many, you can see, you can refer papers, research papers are, so many research papers are there in different aspects they are doing for different products. So these are some of the tasks given by my students when we are doing this about the sustainability. We are doing some type of task like this. So students can be also encouraged when you are when they are doing doing their any work or project, everything when they are advised to do this analysis also in the project report. So then this will be because this is going to be a mandatory one for the future, right? So we can implement this in every aspect. So this is a simple survey taken. So around us, there are so many things, but we are not considering anything around us, right? So even some place will be there nearby your place. It will be used, unused place for so many years. Some building you may see there. It may be a very old industry. The industry may use some chemicals. Will you think about it? What happens to that chemicals or any places left over like that? So are we taking any responsibility on us to what is happening in the particular building which is left over for a long period? Or when you are living in a place or in an industry, when you are working, you can see this kind of oils everywhere. Okay, in an industry or nearby workshops also you can see. This is a waste lube oil spilled on the resort ground near power house. Here in Maldives, there are so many resorts are there. Okay, so you all know Maldives is a tourism industry. The tourism industry is very good in Maldives. So there are here tourists will come from all over the world. So we are having so many resorts here. So in resort for industry and as well as for powerhouse, they are using lube oils. This is a waste lube oil. Okay, so a student done a survey and then he has estimated that. So total used lube oil available from the resort, from single resort per annum is 530 tons. So also the waste oil cleaned, waste oil to cleaned lube oil is 504 tons. So from this 250 ml of cleaned oil can be used for producing a black color bags, which we are saying as a dustbin bags now, can be produced, can be manufactured using this lube oil. So why we have to depend on again new energy and again new investment for the bags which we are producing for dustbin bags. So we are seeing so much of spilled out lube oils everywhere. So why we can't use use that things to produce a black color bags? So if you are thinking in this manner, this is called life cycle thinking. It's a very simple way you can do. You can analyze in every aspects. So we have banned plastic bags, right? So in so many countries, the plastic bags are banned. So what are the ways, what are the other things we can do? When we are thinking about a new type of bags, we can go for a recycled one like this. Production of black color bags per annum is 2 million. We can produce using the spilled waste lube oil. So what is the ratio? 25% of ratio is increasing per annum. So production growth of second year is 2.52 million. So when it is properly done, so this is a simple survey we have done. But when it is properly done, in further we can do some more research on it. We can use it as another type of alternate fuel also. It may be. So to conclude, life cycle analysis helps to improve the environmental conditions by proper analysis and proper steps taken. So for example, extending product life, substituting materials, improving collection efficiencies, and improving waste management. So undoubtedly, LCA is an essential tool for achieving sustainability. So we will think in life cycle manner, and we will do life cycle thinking for every aspect, for every product we are using in house, or when you are using in your workplace, in your office, or in your organization, everywhere. And then we will all work together for the betterment of the environment. Thank you. Any queries from the audience?
Thank you, ma'am. Thank you, Dr. Nasina.
Thank you so
Thank
much.
you for sharing your ideas on sustainability. We are indeed happy that you joined as a speaker, ma'am. Thank you. Thank you so much.
Thank you. Thank you so much. Thank you for giving me this opportunity. Especially, I would congratulate Joe for this work, and then Joe and team. Congratulations. So, am I audible? Are you hearing me?
Thank
Yes. Are you hearing me? Oh, okay. So congratulations for the team, for the conference team. Especially, I want to thank Joe Patrick for the opportunity given to me. So let us join again in another occasion for these kind of things. We can do something for our environment. And thank you so much. Do well. Congratulations for all the participants for your presentations, your papers, everything. Thank you. Thank you so much. May I sign out?
Thank you.
Okay.
Yes, ma'am. Yes, ma'am.
Okay.
You may sign out.
Yeah.
Have a nice day, ma'am. Thank you.
Thank you. Thank you. Have a good day. Thank you. Bye.
It was nice presentation. I'm very happy to you are sharing.
We have another keynote speaker, Dr. Vetrivel, sir. Good morning, sir.
Good morning, ma'am. Good morning. Whether I am audible or not?
Yes, sir, you are audible.
Okay, fine, ma'am. Fine. Okay. So, yes, we can start, I guess.
Let me introduce the.
Yeah. Just you complete your
I'll give you a
formalities,
small
ma'am.
introduction.
Okay, fine.
Okay. Thank you so much, sir. I'm very happy and elated to introduce the keynote speaker, Dr. Vetrivel, sir, Professor, Department of Mechanical Engineering, Chandigarh College of Engineering and Technology. Hailing from Tirunelveli, Dr. Vetrivel holds a bachelor degree in Mechanical Engineering and master degree in Production Engineering, doctoral degree in Mechanical Engineering. His area of specialization includes powder metallurgy, nanocomposites, smart manufacturing, tribology, and production engineering. Dr. Vettuel has published more than 90 papers in various national and international journals. He has published more than 15 papers in various conferences, and he has also published 4 books and 3 patents. His academic credentials are exemplary. Dr. Vettuel is an invited guest for conferences and lectures. His extraordinary academic performance is well recognized. We are indeed happy to have you as the key speaker, sir, today. The platform is yours.
Okay, thank you. Thanks for your nice introduction, ma'am. Okay, so once again, I thank the opportunity given to me from Mother Teresa College of Engineering to Green, right? Okay, and also I take this opportunity to thank one of my friend Ravindran. He contacted me and so I accepted this lecture. And now we are at the beginning stage of the presentation. Now we can go for the presentation slide.
Sure, sir, sure.
My slide is visible or not? I'm just confirm.
Sir, your screen is visible.
Smart materials and sustainable composites. It is visible? Actually, it is showing that your screen sharing is fast.
Screen is fast. Let me check, sir. 1 second.
Okay, please.
Sir, your screen is visible, sir.
Screen is visible,
sir, your screen is visible. Yeah, yes, sir. Yes, sir.
Okay, so then
Okay.
I can start.
Thank you, sir. Thank you.
Okay, so good morning to all. So my presentation is about the smart materials and the sustainable composites. So before going to discuss about the smart materials and the sustainable materials, what is engineering materials, what is smart materials, what is sustainable materials? These things are very important as a metallurgist. So actually, basically, the materials are classified into 2 categories. One is metallic materials, and another one is non-metallic materials. The metallic material, it has been again classified into 2 categories. One is ferrous material, and another one is non-ferrous materials. So, what is metallic material? It contains iron component or no iron component. Based on that, it is classified as 2 categories. One is ferrous. Actually, normally it consists of iron component, that is Fe content, and the non-ferrous materials. It doesn't have any iron component. They comes under the pure materials without Fe. And non-metals. Again, metals, non-metals. Non-metals are polymers. So the materials, those who are not comes under the category of metals, they comes under non-metals, the polymers, ceramics, etc. They comes under the non-metals. Again, polymers, there are 2 categories are there. One is thermo polymers and another one is thermostatic polymers. Actually, some polymers can be reusable, right? Recyclable. They comes under thermopolymers and or thermoplastics. And some polymers or plastics cannot be reused, cannot be recycled. So they comes under the thermostatic polymers, and the ceramics are material in the form of their oxides, carbides, borides, They named as ceramics. Actually, these materials having brittle nature, but the metals and the polymers, their behavior is entirely different. The metals having some brittle metals also there, some ductile materials also there, polymers also. But the polymers, their melting temperature is low as compared to these metallic materials. Okay, most of the metallic materials are crystalline in nature. What is crystalline? The arrangement of atoms. The arrangement of atoms are repetitive, or periodic, or there is cyclic manner or a repetitive manner. Then it is called as crystalline materials. So crystalline materials have materials. The good thing is they are having unique properties. For example, it may be in the form of simple cubic, body center cubic, face center cubic, or hexagonally closed pack structure. So due to the repetitive or periodic arrangement, their behaviors like the thermal conductivity, electrical conductivity is somewhat unique and high as compared to this polymer. Even though the polymers they have made with the chain, we are using due to their high melting temperature, low melting temperature, we can't use for some specific mechanical application. This is the disadvantage of polymers. But even though we can use the polymers for some specific engineering application with the low melting temperature, and the ceramics we are preferably using for high melting temperature and some insulators or insulation based applications we are using. So this is the small introduction about the engineering materials we are using in day-by-day applications, right? So these are the this is the historical era of material science. Actually, we have crossed around 4 stages, actually: stone stage, bronze age, iron age, and synthetic age, synthetic materials age. In the stone age, this is the beginning of material science. Actually, here we use the stone as material or rock materials as a material for some utensils or some other applications for day-to-day life. They use, then they mixed some powder with copper and they identified bronze, that is brass. Bronze, everyone familiar. Copper with zinc, that is brass, and the copper with the tin, that is bronze. So in the bronze, actually the cost of the tin, it is abundantly available as well as it is very cheap, and the melting temperature of the stone is tin is very less. And then we enter into iron age. So in the iron age, we used steel and cast iron for the various engineering applications. Steel is nothing but the material which having less than 2% of carbon, and more than 2% of carbon, then it is called as cast iron. We have used steel as well as cast iron for some engineering applications in the Middle Age, and the synthetic materials, that is artificial materials and natural materials, they combine together. They made for some specific applications. They are called as synthetic materials, and resin-based material, they also comes under the synthetic materials. And now we are at the age of smart materials. What is smart materials? That is a good definition. Actually, we studied something in engineering materials or some strength of materials about the bulk materials or three-dimensional materials. So, for example, we are applying some external load on a bulk material or a three-dimensional material, it will undergo some major deformation, right? If the deformation may be a permanent or unpermanent, that is not a question. But it should, if there is changes, there must be a change in physical properties. What is physical properties and mechanical properties? We should aware that mechanical properties, actually nowadays we are processing or manufacturing some new material, maybe metallic material or alloy or composite materials, whatever it may be. We are concentrating about their mechanical properties, right? What about the tensile strength, the hardness, the toughness, then fracture? These things we are concentrating. Their tribological properties we are concentrating. But the little attention has been taken in their physical properties. So what is physical properties? There is melting temperature, flow properties, density, appearance, right? So these things. So if a material, if we alter the physical properties of the material with some response to some specific stimuli or stimulus input, we are so during in a simple stress strain study, what we are doing, we are applying some external load for deforming the material. Okay, in the similar way, we are applying we will disturb the material with some electric input or magnetic input. So the material will respond. The material will respond something with respect to this specific stimuli input. Then these materials are called as smart materials. Okay, and self-adoption characteristics. Actually, self-adoption materials. So what is self-adoption materials? So with respect to small structural variation causes or the response. It creates some response. These materials are called as shape memory materials, or we can say that shape memory alloys. So our presentation is something about the shape memory alloy or shape memory materials, and so where the shape memory alloys having important role. So it plays an important role in some mechanical machineries. Mechanical machineries and electrical and electronics sensors based actuating system actuators. We are using this smart materials actually. So how already we discussed in the previous slide something about the stimuli. Actually, for example, there is some input and output parameters. Okay, for example, there is a system. We are disturbing the system with some input parameters, but the corresponding response, that is output, we should the variation should be there. So that is called as the smart materials. Suppose if the material response is or the unique property. Okay, for example, we are changing. There is without any major variation, a small variation which creates enormous or huge amount of variation in output response. These materials are called as intelligent materials, right? So so in the day-to-day life, the physical nobody is not, we can't say nobody, very limited persons are interested to study the changing the physical nature of the material, and and also the important thing, the physical properties which cannot be altered significantly. That is one of the disadvantage. So but the minor variation, minor change in the physical properties should play in response. Okay, these things we are going to discuss how we are preparing the materials, this shape memory or smart materials. But most of the researchers, they are concentrating about the properties of smart materials, like their volume effect, their tensile effect, viscosity, because these things can be altered or varied with the addition of some secondary particles like reinforcements we are using while processing the materials. So these effects are most of the researchers are studying. Okay, so and this is the comparison about the traditional structure and the smart structure. Actually, for a design, for a certain, we are, for example, we are processing a bulk material. For example, aluminium, silicon carbide. So this is a composite or aluminium. Actually, we know that the melting temperature of aluminium 670 degrees centigrade. The tensile strength, it is from 150 Newton per millimeter square or something. So for example, we are designing for certain performance. So we have to process aluminium. It is for 150 Newton per millimeter square. Okay, it is not, it will not support more than that. So specific limit. Okay, so we have to design the performance for some certain load or some lifespan. Okay, and also it is unable to modify its specification. It is a disadvantage, but in the smart structures can accommodate an unpredictable environment. For any environment, we can use it. But the environment condition also one of the parameter which plays an important role. For we are traveling on the four-way or something. Some boards are visible only in the night. So they are due to their environmental change. So it responds with respect to the environmental condition. Here the environmental condition is the input parameter. So the board will reflect. Okay. So this is smart materials. So these materials comes under smart category and can meet the exacting performance requirement and also offer more efficient solution for a wide range of applications. So these are I have listed some common smart materials, that is piezoelectric materials. So these materials, when we disturb with some electric load, it will vibrate. So we can utilize this vibration for some specific smart applications. Next, electrorestrictive materials, magnetorestrictive material, rheological materials, thermoresponsive materials, electrochromic materials, fluorescence, biometric materials, biomimetric material, smart gels. So these are the common materials which plays in what a wide variety of applications in every day-to-day life. And we are going to discuss about smart shape memory alloy. This is also one of the smart materials. Actually, it works under the principle of shape memory effect. Okay, what is shape memory effect? And super elasticity. So we are going to discuss about this two effect. Okay, that is pseudo elasticity or super elasticity. So actually, some deformation is permanent. Okay, that is called as, actually there are two types of deformation is there. One is elastic deformation and another one is plastic deformation. Actually, so alloy, we are talking about alloys. Alloy, what is alloy? Alloy is nothing but a mixture of two or more material which has been made with the complete fusion. Okay, for example, aluminum silicon carbide we will take. This is the aluminum and the silicon carbide. Aluminum is a base material, or we can say that it is matrix, and the silicon carbide is a reinforcement. The role of matrix, which is used to bind the reinforcement particle, and the reinforcement SiC, which gives the strength to the matrix. So normally we are using aluminum SiC alloy as a wheel material. Some alloy wheel we are manufacturing. Okay, so how we are processing this material? Actually, we have two different crucible. One is for aluminum molten metal and another one is for silicon carbide molten metal. The melting temperature of aluminum is 670 degrees centigrade. Normally, we can say 700, 750 degrees centigrade. Actually, the exact melting temperature of aluminum 676 degrees centigrade. And the melting temperature of silicon carbide, it is more than 2000 degrees centigrade. So we have heated the aluminum in different crucible and SiC in different crucible. What we are going to do, we are going to mix or process the alloy. So we have to pour the silicon carbide molten metal into the aluminum melt. Okay, then what happens? So the aluminum starts to fire because it is not able to withstand this particular 2000 degrees centigrade. So immediately we have to give the huge or very raster or fast agitation or stirring we have to provide, and then immediately we have to do faster solidification. So this is now called as alloy. The composite processing is different and alloy processing is different. So then how we can identify whether this is alloy? Alloy also the mixture of two or more material, and the composite also the mixture of two or more material. And the alloy, it is a homogeneous mixture. How we can say that it is homogeneous mixture? So actually we have poured the SiC into the aluminum molten metal. The aluminum melt starts to fire. We have given the very fast stirring. Okay, so we got a uniform distribution. So during the microscopic examination, it is quite difficult to identify this is silicon carbide particle and this is aluminum particle. It is difficult, as in the case of alloy, right? So this is the case, but in the composite, it is a heterogeneous mixture. We can able to identify the phase after during the microscopic examination. So this is the difference between the alloy and the composite, and also the alloys we can say that it is isentropic because it is homogeneously mixed, but the composite we can't 100% we can't say that it is not homogeneous, but we are saying that it is isentropic. The strength of the property is same in all the direction. But as per the composite concerned, composite material concerned, so the way in which processing and the way the phase we are embedding or enforcing the reinforcement direction, which gives more property and strength as compared to the other sides, maybe longitudinal or lateral direction. So fiber orientation direction and fiber orientation, which plays an important role. Okay, this is the some discussion about the alloys, right? And here, so we are going to the discussion the shape. Even after severe deformation, the shape memory alloy is deformed in the cold shape, and the shape remains stable until we have to disturb with some external heat. So we are utilizing these property for some smart applications. So these materials or these alloys are called as shape memory alloy. Here the structural change, this is very, very important. It is observed that the structural variation or changes at the atomic contributes to the unique properties of the material. So this is the discussion about the shape memory alloy. So here something I have mentioned, martensite, austenite, something. Okay, so first we will discuss what is austenite. Actually, this is one structural or one phase of iron. Okay, iron. For example, we will consider the steel. Okay, steel, it is a mixture or a solid solution of iron and carbon. Okay, so it has some solubility limit also. The solubility limit of carbon in iron is maximum 6.67% theoretically. But experimentally, it is proved that maximum 4.7%. That is the maximum possible limit. Okay, now we are discussing about the ferrites. That is alpha ferrites. We are alpha, gamma, and delta. These are the various phases in the various form of iron. Iron is a allotrophic material. Okay, what is allotrophic material? Actually, alpha, gamma, delta. What is alpha? That is a BCC structure iron. It is called as ferrite. The solubility of carbon in this ferrite is only 0.0025%, right? And if we heat the ferrite to a temperature range above 723 degrees centigrade, the 723 or 725, this temperature is called as a lower critical temperature. After crossing this lower critical temperature, the phase, the alpha phase, has been changed into the gamma phase. So here there is a structural variation. This structural variation plays an important role for this smart application. Okay, so for alpha, what is the crystal structure? BCC, body center cubic crystal structure, has been changed into gamma austenite. Gamma austenite, it is stable structure beyond 723 degrees centigrade, but it is in solid form. That is very, very important. Alpha also solid form and the gamma also solid form. Okay, but when it crosses the 723 degrees centigrade, the structure available in the iron or the steel is gamma austenite. Okay, now we are at the stage of gamma, that is gamma austenite form, that is FCC, phase center cubic. The structural form is FCC, phase center cubic, right? We are utilizing this temperature variation for the particular application in the shape memory alloy. So because we are most of the shape memory alloy, we are using some iron and a nickel based system. So binary system actually. So two materials are involved, binary alloys. And as per the gamma arsenate, it is a stable form of iron. Okay, it is good. Then if we allow to cool from gamma to alpha, gamma also solid form and alpha also solid form. If we are initially we heated a temperature from room temperature to above 723 degrees centigrade, it is in gamma. Then we are allowing to solidify or cool the material. Then it will follow. Now it is up to the steel type. Actually, there are two types of steel. One is hypo steel and another one is hyper steel. Okay, so that is 0.8%, which classify the steel less than 0.8 then hypo steel, and more than 0.8% of carbon, then it is hyper steel. So the 0.8, it is split euctectoid steel, whether it is hypo or hyper euctectoid. So then there is a possibility of one reaction. That reaction is called euctectoid reaction. So the what is euctectoid reaction? Now the gamma is split into pure light. Gamma split into pure light, that is gamma arsenate into pure light. If you do very slow cooling, this is very important. If you do very slow cooling, it may be furnace cooling. If you perform the very slow cooling, the way is different. We will get gamma into alpha plus Fe3C, where alpha is ferrite and Fe3 is cementite. Okay, so the mixture of alpha plus Fe3C, that is called as pure light. Okay, this is one way. But if we allow to cool in a very fast raster cooling, if we are providing very fast cooling, when we have heated a material iron or the steel to above 723 degrees centigrade, we reaches the arsenizing, or we have done arsenizing. What is meant by arsenizing? Arsenizing, it is the process of converting entire ferrite into arsenite. Okay, so where arsenizing will happen above 723 degrees centigrade. Now we are in 723 degrees centigrade. We are doing very fast cooling, or we are providing with some brine solution or some water. With the help of that, we are reaching within a fraction of second. We reaches the room temperature. Then we won't get the pure light structure. So, for example, the gamma split into alpha plus Fe3. See, that is a common reaction. That is euctectoid reaction. One solid split into two different solid. That is called as euctectoid reaction. But at the same time, if you are not eligible, if you do very fast cooling, we won't get the alpha ferrite. Instead of alpha ferrite, we will get the martensite structure. The martensite structure is the hard and brittle structure of iron or steel. So these applications we are going to use in the smart material. These materials are called as shape memory alloy. For example, this is the first stage. So we have converted this arsenite, gamma arsenite into martensite. How we have done? We have heated the material to above 723 degrees centigrade. We have completed the arsenizing. Then we have did a very fast cooling. Now the structure available in the material or in the steel or iron is in the form of martensite. The martensite is the brittle form or very hard structure, hard form or hard structure of steel. Okay, what we are doing? We are going to apply some load. We are applying some external load by using some external device, or for a practice, or for example, I have provided two hands in its two ends. What happened? There is a possibility of the arrangement is like simply supported, both the end having support, so it will bend like this. So there is a formation of small curvature, right? So now the deformation available in the material is permanent. Okay, it is not not elastic deformation. So what is elastic deformation? We have to apply some external load, it will deform, and after the removal of the external load, it will come back to its original state. That is elastic deformation. But here the deformation is permanent. We are applying some external load. We are bending the particular steel. So we have got some permanent bending. Okay, so we are going to utilize this bending for some applications, right? We have deformed. Now what happened? Iron is the best example for polymorphism as well as allotrophic material. What is polymorphism? The material can exist more than one form. For example, in room temperature, it is available in alpha form, that is BCC structure. If we raise the temperature above 723 degrees centigrade, then it exists in gamma form. The gamma is FCC structure. Again, if we increase the temperature more than above 1410 degrees centigrade, it is in the form of delta ferrite, alpha ferrite, gamma austenite, and delta ferrite. So these are the various stages. So if the process is reversible, or for example, now we are 1410 degrees centigrade, if we allow to cool, when it reaches the some region, the structure, crystal structure available in the FCC, and below 723 degrees centigrade, again it is in FCC structure, sorry, BCC structure, that is alpha ferrite, but the heating and cooling process should be a very slow process. Okay, if it is fast, then the effect will be something different. Now we have made the permanent deformation on the particular shape memory alloy. Then what we are increasing the heat. Again, the material will comes to its original state with this external stimuli. Now the heating, this is called as external stimuli. This, with respect to this external stimuli, it will come back to its original state. For example, this is a martensitic steel. We have applied some load, it has been deformed, but it remains in the form of martensite. Now this is the permanent or deformed martensite structure. Now we are applying heat. Now it will get, whenever it reaches the 723 degrees centigrade, the structure remains gamma austenite. Okay, gamma austenite. It is also a solid form. If we again allow to cool very fast, then it will come back to martensite state. Okay, so this heating and cooling, fast cooling, the heating and the cooling control some control or some response. Okay, perform some response. This is called as a shape memory alloys, right? We are going to discuss about the types of shape memory alloys. So one is one-way shape memory alloy and another one is two-way shape memory alloy. So actually, if we get or it exhibits or produce the shape memory effect with respect to heating, for example, we have considered in the last slide with respect to the heating, only heating, then it should have one-way shape memory alloy, but it responds for heating as well as cooling. So if we control two operations at a time, then it is called as there is a two-way shape memory alloy. And these are the common or normal applications of shape memory alloys. We are using some aircraft, antenna, telescoping, triggering, next actuator, clutch system, thermostats, oil pressure controls, and high pressure shielding plugs we are using. And these are the few more smart materials, that is shape memory alloy. So here are the external stimuli is temperature. Next, magnetic shape memory alloy, that is magnetic field and piezoelectric effect. We are providing some electrical load for disturbance, and the magnetostructive material, again magnetic field. And so some smart materials I have listed here. And the smart systems are actually, what are the response we will, or the applications, that is sensor, actuators, and processes. We are using these materials, and these are the stimuli for the particular applications, right? So I have this slide I have mentioned one nickel, manganese, and gallium alloy. So it is a novel frequently used magnetic actuator, and it possesses cubic structure. Actually, for example, here the nickel, manganese, gallium, nickel having cubic structure, and the manganese and the gallium having face center cubic, even though the alloy having uniform microstructure. The structure is very, very important as with respect to the shape memory alloy. And so here the structure available, it has a cubic crystal structure. How we are making this crystal structure, there are two ways we can process. There is top down method and bottom up method. So actually, if we process from bottom to top, then we can make the bulk material. If we process from top to bottom, then we will get converting this bulk material into some crystalline nano structured materials. or a nano. For example, see here there is a bulk material. What we are doing, we are just we follow top-down method. So top-down method it is suitable for making the powders, right? The powders may be microns or nanoscale, or nano powders or nano materials. It is not a question. What we are doing, we are converting, breaking this coarse bulk material, bulk into the powder. Okay, the size may be microns, then cluster powder, agglomerated powder, then finally small nano powders, right? So in the bottom up process, what we are doing, we are mixing the powder and we are making agglomerating or clustering the powder. Then we are making mixing or something. Then we are making the bulk material. So these things, what are the important stages for making this powder, for making the shape memory alloy? So mechanical milling or alloying, okay, we can say both are common. And this is what is milling and alloy? It is a process of reducing the particle size as well as mixing simultaneously to the form. And here the material transfer takes place uniformly or homogeneously. How it takes place? For example, mechanical alloying. What is mechanical alloying? It is a process of mixing different metal powder or elemental powder or metal with ceramic powder, whatever it may be. We have to mill. What is milling? So it is a process of reducing the particle size. 1 minute, please wait. Hello. Sir, சொல்லுங்க. ஓ அப்படியா, ஒரு 10 minutes எடுத்துக்கிட்டுமா சார்? ஓகே 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 ஓ ரைட் okay. So now I fasten my presentation. Actually, this mechanical milling and alloying technique, which is used for mixing, reducing the particle size as well as the mixing as well as reducing the particle size. Actually, for example, the powder A and powder B, which has been, suppose if we are going to mix this powder A and powder B, so we normally are using hardened steel ball or tungsten carbide ball. So there is a continuous pollution or which exists. For example, just to see, this is the ball we are using. These are the mixed or the mixture of powder A and powder B. So what happened? There is a continuous collision exists between the ball. Whenever the powder particle crossing through this ball, there is a fracture surface appearing. So here the important parameter which it is fixed, there is ball to powder ratio. So if you increasing the ball to powder ratio, again we will get the very fast mixing. So this is a 2-jar mixing system. So we can use the 2 chamber for mixing. So here we can use a higher ball to powder ratio, then we will get the very faster rate of mixing, right? So these are the common material characterization techniques: XRD, SEM, TEM, EDS, DSE, and the XPS system. So and the X-ray diffraction, XRD, which is used to measure the average grain size or crystal orientation or crystalline size of the material, and the SEM term, it is used for microstructural examination, elemental analysis. DSE, which is used to technique temperature, used to identify the heat flow related with the thermal transition of material, and the XPS system also about the elemental composition and the surface chemical imaging and the depth profiling of any material. And now we are going to one of the latest technology. What is sustainable biocomposite? Actually, it is nothing but the material or composite material which is having renewable, recyclable, and biodegradable materials, which are called as sustainable biocomposites. Actually, these materials are having good environmental acceptability and commercial viability, right? So these are the advantages of biocomposites. Actually, nowadays a lot of researches are going on in sustainable polymers based composite materials. We are using, these are the base materials or matrix material for the biodegradable polymers, and the natural fibers or degradable fibers, which comes under the category of the sustainable fibers. And the global market applications of these polymer-based cellulose or natural fibers. So nowadays it varies. Actually, in up to 2014, it is in 3.1 million metric ton. But over the year, so it is shown it has been increased for 12.7% for the 5-year period. And these are the common applications of biodegradable sustainable biocomposites, which is made through the natural fiber reinforced, and the bases in the polymers can be obtained. The input parameter, we can change the behavior with the help of the glass transition temperature, melting temperature, and flow temperature. And these are the common or most probably used already. This is available techniques, that is extrusion compression molding, injection molding, thermoforming, blow molding, hand layup technique, spray layup technique, filament binding, resin transfer molding. But these techniques are existing, right? So in the very beginning, we used the hand layup technique, then followed by, in order to improve the mechanical properties of the material, and with less porosity, we have used the compression molding techniques. But latest, we are using the microwave assisted compression molding. It has wide variety of application as well as advantages. We are going to discuss about the advantages in microwave assisted compression molding. It is a cost effective techniques and the environmental friendly, and it has with the composite, the process through this microwave assisted biocomposites having improved quality and properties. So what is the thing? What is the novel thing in this microwave assisted material? That is interaction. Suppose if for example, quartz material. So the microwave interacts with the materials selectively. For example, we will discuss first the composite. For example, multiphase material. So the multiphase material consists of the matrix material and the reinforcement. This is reinforcement. And so suppose if we apply the microwaves on the particular material, the interaction starts where the reinforcement presence, because their dielectric properties are different. Okay, microwave interactions normally depends upon their dielectric properties of irradiated material. Here two different materials are there, so their irradiation behavior is different and dielectric properties are there. So but in the reinforcement having more dielectric properties, so the interaction start from the where the reinforcement particle located. And also bulk material, for example, it is made up of aluminum alone, so this is a pure material, so then there is no interaction. So here two materials are there, so the interaction is available or starts from the reinforcement point of view. Okay, just next in this slide, the two things are very important. This is normal heating and this is microwave heating. So from this slide you can clearly understand that what is the major difference. So how we can transfer the heat? There are three ways. Okay, conduction, convection, and radiation. So, but we within the solid body there is conduction. We are doing conduction heat transfer. So we are transferring heat from the outer side. So what happened? So the heat is transferred from the outer periphery to the inner core. This is the core. So we are transferring the heat from outside to inner. So here, what is the main disadvantage? Here there is a temperature difference. Due to the temperature difference, there is a high temperature gradient different. That is called as gradient. High temperature gradient is there. But in the case of microwave heating, the interaction or the heating starts from the inner core. That is the main difference. So then even though the small amount of gradient is there, but it is not much. That is the main difference. So due to that, we can get the uniform property very fast rate. So this is the manufacturing using microwave assisted compression molding. So this is the arrangement of atoms, right? So we are generating the microwaves and we are passing the microwaves through the atoms. Now the interaction starts from its inner core, right? So whenever we pass the microwaves, immediately it reaches the cores, right? Whenever it reaches the core, the interaction starts and it will the waves passing through this manner. And what happens? There is a diffusion takes place from the inner atoms to the nearby atom. So there is a fusion takes place, and there is a small amount of pores are present in the material, which can be removed with the application of even small amount of load. But in the compression molding, we are applying huge amount of load. But in the case of micro assisted compression molding, the very less load is more than sufficient to heat this, to make this sustainable composites, right? So this is the case with this is the sample, this is the scanning electron microscopic image of the material. So without any applying sample surface, after microwave processing, without application of pressure, but after, so now in this stage we have measured the size of the pores or the hole size in longitudinal and lateral direction. It is showing 174.9 micrometer in the lateral direction and 60 micrometer in the lateral direction and 174 in longitudinal direction. But whenever we apply some external load, small load, okay, it is 0.02 megapascal, there is, it is free from any of the hole. So any of the porosity, it is the one of the most suitable manufacturing method for processing of polymer based biocomposites. You can also follow this method. So it is more than 2000 rupees. Rupees is more than sufficient to make this heating system. You can make it in your own lab also, and you can make the samples free from any pores or any free from any of the defects. So this is the bonding strength and behavior. And finally, now we are in the conclusion stage. If you have any clarification, actually due to time constraint, I stop my presentation. So if you have any clarification or something, you can contact me through mobile or mail ID. So I have attached in this slide. So any clarification or discussion, we can do 1 minute. Okay. Any questions?
Thank you, sir. Thank you, sir, for your presentation. We're also sorry for the time constraint. We have another keynote speaker also online. Thank you so much, sir.
Okay. Thank you so much. Thanks for the opportunity. So I thank all the mechanical department faculty, especially Ravindran and management for providing me the opportunity. Thank you, one and all. Okay, fine.
Thank you, sir. Thank you so much.
Thank you, fine.
ಅವರು ಸರ್ ರಿಚುವಲ್ ಸರ್ ಇರ್ತಾರೆ ರಿಚುವಲ್ ಸರ್ ಲೈನ್ಲೇ ಇರ್ತಾರೆ ரிச்சுவல் சார் லைன்ல இருக்காங்களா இருங்க நான் இப்போ வரும் சார் hello yeah sir, thank you very much for your wonderful speech and everything. Thank you for your presence and kind acceptance of our invitation also. Really your presentation is if anybody doing their research work in material science, definitely it will be very helpful.
அவ்வளவுதான் லீவ் ஆயிட்டு
Participants, please stay online. We have Dr. Suresh, Associate Professor from NIT Trichy, will be joining us shortly. Please stay online.
Hello.
Good
Can you hear me?
morning, Suresh sir. Good morning, sir.
Good morning. Hear me?
Good morning, sir. We are very happy to have you here as a keynote speaker for the International Conference Smart 22. Let me take some time to introduce you to the participants, sir. I'm very happy to introduce the keynote speaker of the day, Dr. Suresh, Associate Professor, Department of Mechanical Engineering, NIT Trichy. Dr. Suresh graduated in Mechanical Engineering from Madurai Kamaraj University. He holds a Master's in Energy Engineering from Regional Engineering College and his doctoral degree from NIT Trichy. He has more than 22 years of teaching experience. His achievements include publications in international journals, conferences, and chapters. And to add on, he is listed in the top 2% scientist list in the world in the domain of mechanical engineering. He holds a Sir C.V. Raman Award from St. Peter's Institute of Higher Education and Research. He has received Shastri Mobility Program Award from Shastri Indo-Canadian Institute. His research paper has been selected for the JMST Award for the most cited paper of the year. He has completed a number of sponsored and consultancy projects. His academic excellence has no bounds. Apart from all the laurels, recognition, and credentials Dr. Suresh holds, he is a man of simplicity with justice mind. We are indeed happy to have you with us today, sir.
Thank you, madam. Thank you, madam. Can you hear me?
Thank you, sir. Thank you. Sir, your slides are visible, sir. Your audio is also
Okay.
clear. Thank you, sir. Suresh, sir, the platform is yours. You can
Okay.
Thank you, sir. Thank you.
Okay. Thank you, friends. Thank you so much. I hope you can able to see my presentation. I'm very thankful to Madam for a nice introduction. As well, I'd like to thank Dr. Ravindran for the great opportunity to share few thoughts of my research work on the conference on sustainable materials and advances in renewable energy. Since the time given to me is only for 10 minutes, just let me do a brief introduction about my nanotechnology research lab, which I established in the year of 2007. Last 15 years exactly, I completed my 15-year service in NIT. I joined on April 30th. So I'm happy to give a keynote address on this conference. And this is my profile. You can contact me at any time on myself today. And I hope this is my phone number and mail ID and my scholar citations. I hope you get some idea about myself. And let me come to this. This is the now time is 11:48. 11:58. I will complete. The overview about my research career at NIT Technology Research Lab, which I established in 2007. And basically, I am the heat transfer person where I focused on, started the research transfer enhancement techniques. There are different enhancement techniques when you look at that, the passive device and active device. And see, friends, I'll give just a glimpse on what we have done it so far. If you have any doubt, maybe you can interact at the end of the session, or otherwise, I hope you can contact me at later part of time. So heat transfer enhancement techniques, when you look at, there are either we can increasing the heat transfer, or it may be some point of time we need to decreasing the heat transfer. There are many examples for enhancing the heat transfer that we say that heat transfer enhancement techniques. And in this heat transfer enhancement technique, which is only slide which I am going to present. And when you look at here, when you take an internal flows where we can insert some passive devices like inserts, and that will break the boundary layer and we can increase the heat transfer. That is the thing. Mostly we focus on the passive device. We cannot even we propose anything active, and the active which consumes some power, so people don't prefer to go for that active technique. So mostly what we prefer to do on passive techniques for heat transfer. And then there are two types. One is for the modification of the surface and the modification of the fluid being used in the heat transfer applications. So modification of the surface, we can say this photograph where we can see that different type of insert, we can use it and we will enhance the heat transfer. And the fluid modification, we say that the nanotechnology which comes to role, that's what we have started the lab called nanotechnology. And this is called a nanofluid, where the nanoparticles are added to the base fluid. Basically, when you look at the nanofluids, the heat transfer fluids, where it has lower thermal conductivity, so that we need to improve. And that idea is, it's not a new one, because when you look at the literatures, people would say in 1950s, there are many researchers has tried this, but unfortunately, the particle size and other things did not give much impression on the progress of the research. But later on, this nanotechnology once evolved, the nanomaterial can be synthesized, and that being the additives for this nanofluid. So that what I want to communicate in this, the fluid can be modified, the fluid properties can be modified, the fluid thermal conductivity can be altered or increased or enhanced with the help of adding the nanomaterials. And then we study that we usually characterize this, and after characterization, we measure the properties. Once it is a favorable condition for us, we move on to this other area where that electronic cooling will be the another application for the nanofluids. So we use that the prepared nanofluid instead of the dielectric fluids. Dielectric fluids are water. We mixed with some nanoparticles, study the properties, and applied the application on the electronic cooling. Electronic cooling. Then, as I mentioned, that there are two kinds. One is modifying the fluid, another one is modifying the surface. So that earlier what we did is simple work. We inserted the insert. You can look at here. We will insert the some insert and do this. And another one is the fluid modified nanoparticle added to the base fluid, and we study the characterization as well as the properties, then applied in the electronic cooling. Then later on, we move on to these nanostructured surfaces. Again, it's another area where we have done quite a lot of research on this creating the nanostructured surfaces. And by the way, enhancing the heat transfer is another work we have carried out. Basically, what we have done it, mainly we focused on the mimic in nature. For example, when you take a lotus leaf, as you all know that the structure which is inside is a nanostructure. That nanostructure we try to mimic it. What is the need, sir? That is, when you look at the lotus leaf, when you spill water over that, that water will collect the dust and jump on it. Maybe you can see this photograph where you can see that water particles are roll on that. That is because of super hydrophobic this nature of this. Because of that, the water, when you spill it on that, the water collect the dust particle and roll it on that. Roll it from this. While rolling, it will collect the dust particles. This is what happening in nature in the lotus leaf. So when you look at the applications in mechanical side in the power plant, as we know that the Indian coals has more ash content. So what will happen when that ash which comes to this, the flue gas which contain ash, when it come and contact the surface, that will try to stick on the surface, or this ash which has very hard materials. So it will try to hit on the surface and peel off the surface, the puncture the surface. To avoid this, if the surface which hate the ash, and then it is easy for ash, this ash will not hate. So that is, instead of fluid phobic, we say that it is a phobic, and hydrophobic or philic. So that's what we have tried this nanostructured surfaces in the power plant where the ash condense is more. We modify the surface from hydrophilic, or we say that instead of philic to phobic. So that once it becomes philic to phobic and the ash will not stick on the surface, by the way, we can enhance the heat transfer. not only enhance the heat transfer, that the lifetime also get increased. At the same time, where we get one more idea after we introduce this, we could see when you look at the other end, the surfaces are hydrophilic, and where the heat transfer will be more, where the steam will come and contact. So when the steam which has more contact with the surface, from the steam to that the heat will be transferred. So that's what we have done in the power plant, both the ends, nanostructured surfaces as well as the we can see that the both we have done it. So when you look at that, the next one, the same combination we have tried in the flow boiling enhancement and then pool boiling. As I need not explain what is flow boiling and pool boiling, where the flow, where there is a flow, and pool, the pool of liquid which is stored in that. Both the applications we have tried this nanostructured surfaces. Depends on the requirement, we have completed that. Then let me move on to that. Next area where we have done quite a lot of research, that is on phase change materials. And the phase change material, change of phase. By the way, when you look at the buildings where the sensible heat storage is stored and facing the problem of increasing the temperature of the wall buildings, and that will radiate the energy by the way we feel hot. I hope you all know that. So nowadays the temperature is keep on increasing, the radiation effect will be more. So to reduce this, we have tried with this phase change material instead of the sensitive heat, where you can store 5 times more energy. Apart from that, then the PCM, which is phase change material, which we shortly say that PCM, so that will be applied in the solar desalination. And again, the solar desalination, not only this, apart from that, we have integrated with other earlier research like nanofluid also integrated, because as I said, earlier we started with the nanofluid only the thermal properties. Later part we have focused on optical properties also. And then we will move on to this, the phase change material application in solar desalination, as well thermal management in space applications. And now at present, we are focusing on the thermal management and vacuum insulation panels and thermoelectric generators. So these three areas where we are recently working on that. Apart from that, so basically it is a combined, so whatever research we are doing, we are combining the earlier research. When you look at the vacuum insulation panels, we have added the PCM inside the insulation panels. The panels can be used in energy efficient buildings. As well, when you look at that thermoelectric generator, so we usually say it is called TEG, the TEG thermoelectric generator. Mostly people say that it has less efficiency. So that less efficiency, we want to improve that. So what we did is that waste energy, that for example, you would say that if you maintain delta T 200 degrees centigrade, for that efficiency will be a maximum of 8%. So remaining 92% of the energy which is applied in the hot side will goes to the cold side and will be get dissipated to the outside, or otherwise the delta T. So what we did is without altering the temperature, we stored that the heat which is wasted, and that heat will be reversed during the night time. So that is called reverse power generation, and we have generator power. So that is the another area we have done the reverse day-night power generation. So apart from that, recently we are entered into the field of the hello. Okay, so recently we have entered into this other area called the additive manufacturing, and see whatever that surface modification and other heat sinks. So we are trying with this 3D printing, through 3D printing. With this, I will stop. If you have any doubt, not doubt, maybe you can interact with me in any one of this area. Thanks for the great opportunity. So it is a keynote speak, which I used my established lab. What are the research work which is ongoing? Friends, over to you. If you have any queries, you can interact with me. Hello?
Hello.
Can you hear me? Okay. please. Madam, over to you. If you have any doubt, you can ask Dr. Ravi.
Yes, sir. I'm there. Right. Anybody have any doubts on that?
Because I just, friends, it is usually I take 2 hours. Sir said only keynote speak. So I have restricted myself. I have given overview that what we have done it so far and what we are doing now. And if you have any specific doubt on any of this area, you can interact with me, or otherwise in later part also you can interact.
Yes, sir. Yes, absolutely, sir. Actually, we are very happy to with you have right now. You are doing wonderful research work in your nanofluids area. We know that. Actually, it's a great opportunity that people know, the students and the participants, right? If you have any doubts on that, you can ask me now. Sir will explain. Otherwise, you can mail to sir. Sir will explain elaborately. It's now the platform to the participants, right? You can raise your doubts if anybody have it. Yeah. Okay, sir. Sir, thank you very much for your wonderful, wonderful presentation. And
Dr. Ravi, thank you, Dr. Ravi. I know that it is a keynote speech, so we cannot take more than that. I really am very much thankful to you for the good opportunity. Thank you, my dear friends. All the best. Thank you. Bye.
Thank you, sir. Thank you, sir. Thank you. Thanks a lot. Okay.
I'm Patrick Sagara.
Yes, sir. Yes, sir. Yes, sir. Sir,
okay, you can present now.
Okay, sir. Thank you, sir.
Okay. Please complete in within 10 minutes, ma'am.
Okay, sir. Okay, sir.
Okay. Your screen is visible now. You can present.
Oh. Okay, sir. So my screen is visible.
Yes, ma'am. It's visible.
Hello.
Yes, ma'am. It's visible. You can start your.
Okay, sir. Thank you, sir. Okay, sir. Good morning to all. Today my topic is autonomous monitoring system, indoor herbaceous plant growth, and introductions. In this slide, I have agriculture plays an important role in the whole life of our economy, and the world's demand for food increases, so the demand for food production is also increased. So we can easily meet the needs of agriculture and consumers by harvesting these crops internally. So we need to make this existing farming system very, very smart. So this makes it much easier to do with food and herb needs. This automation system has allowed the farmers to automate the agricultural monitoring of water level, pH, temperature, humidity, and light intensity. This can be regulated through IoT. It allows the machine-to-machine interactions and controlling the agriculture system autonomously and intelligently. There is no need any human interactions. So finally, we raise the topics related to automation system in indoor farming. And objective of my project is creating a real-time monitoring system to monitor the growth of factors of the plant using this automated system to monitor the plant growing and the light emitting diode lamp. And the post model of my project is an essential need for as in the current pandemic situations. So therefore, it is more beneficial to grow this herb plant indoor. Plant as a indoor. This paper proposes an automated system to monitor the growth of the indoor herbaceous plant from an automated system. It can detect the environment conditions of the plant with the help of the sensors like humidity, temperature, and moisture sensors. The data from the sensor sent into the controller, and which will be stored into this ThinkSpeaks. So finally, it will be analyzed. Here the plant is grown with the help of intensity from a light emitting diode lamp. So it is free from sunlight. That means it does not depend on sunlight. So this model provides a precision agriculture. This is the setup of the plant bed. It consists of herb plant. Here, two types of sensors, that is pH, temperature and humidity sensor is mounted on the soil, and this plant is grown by LED light. So it is free from sunlight. Hardware and software used for this project is Arduino. Hardware used is Arduino UNO, temperature sensor, humidity sensor, and soil moisture sensor. Software used for this project is Proteus tool, Arduino IDE, and ThinkSpeak. This is a circuit diagram of a proposed system. It is simulated by Proteus tool. Components used in this hardware systems are humidity sensor, soil moisture sensor, temperature sensor. That humidity sensor is used to sense the humidity level of the environmental or the plant bed, and soil moisture sensor is used to sense the level of the water content in the soil. Temperature sensor is used to measure the temperature around the plant. Here we are using Arduino UNO. This open electronic platform, so it can be handled by everyone. And this Arduino UNO is both a programmable circuit board and piece of software also. This is the hardware implementations of our project. So it consists of pH sensor, temperature sensor, and humidity sensor. Developed hardware for automation system, which consists of these sensors, are mounted on the plant bed. Here, the amount of water requirement for the plant can be calculated by the heat and humidity, which is sensed by the sensors. Here, the sensor values are collected from the microcontroller to the ThinkSpeaks, and the corresponding value and graph are obtained. The graph of the sensitive value is given below. This is our result of monitoring system. Consists of moisture, light intensity, humidity, and temperature level. It shows the environmental conditions of the plant bed. This is for day 1, and this is for day 2. Actually, we are collecting more than 20 days, but here we are giving only 2 days for the sample. These are the value for the sensitive value, that is time, moisture, temperature, humidity, and light intensity. For 2 days we are giving. So conclusions, this work is greatly helps to study the ecosystem of the herbaceous plant to identify the beneficial of the plant. The goal of this work is to monitor the growth status of the plant each day. Also, the plant is grown in LED light. So climate change does not affect the growth of the herbaceous plant. So the proposed system is to provide the quality of the herb. These are all the references we have taken for this project. Thank you, sir.
Thank you, ma'am. The presentation is quite nice. Can we do this same setup for a large scale?
Yes, sir. This one, sir.
The large scale, can we do the setup for the large scale? You check for a single plant, can it can be for the more than 10?
Sir, your voice is not audible, sir. Can you please explain again?
Is audible, ma'am? Your voice is audible?
Yes, sir. Yes, sir. This
So
slide, sir.
Tested for. I'm asking about can we do this for a large scale? You planning for a single plant? I think so. Sure. You test for one plant or with multiples of plants? Go to the setup page. Up.
Sir, actually, we are ground the plant by LED light.
Yes, this use based on a single panel on here. We can use this setup for a large scale or not.
No, sir, it is only for indoor application, sir.
Okay.
So we are using this indoor applications. So it will improve. It will reduces the farmers' workload also, sir.
Okay, ma'am. Okay, ma'am. Thank you for your presentation.
Okay, sir. Thank you, sir.
Okay, ma'am.
Okay, sir.
Yeah. Morning, Godima. The next part is Molly Gordy from Manariman College. Are you here? Molly Gordy. Are you online? We'll go for the next part. Bhupaji from Manariman College. Are you there?
Sam audible?
Yeah, you can start your presentation.
Suggestions.
Takes more time. Can you see that? You can start your presentation. Yeah. Yeah. Okay.
Speaker is not working with you.
Can I send my paper? Hello. Hello. Can I start my presentation?
Start.
Yeah, thank you.
Can I start? Okay, study and experimental investigation on corrosion behavior of electricity on electrolysis and nickel boron coating on steel. First of all, just some outlines. There is no time for running out. So just introduction, material and methodology, results and discussion. Just I'm giving the abstract. The purpose of what is the nanomaterial, just now the speaker will explain different kind of nanomaterials, how could be we are going to be doing all the research on that. So in the AL2O3, I'm going to be tested on the electrolysis techniques of using nickel, boron, and nickel samples. That different corrosion testing like wet and dry conditions I have to do. So in this case, the true analysis of oil bath, here the oil bath parameters I'm going to use the fabricated how it could be. So that properties, introductions of the objective. What is my main objective is to develop corrosion resistance coating for the steel pipe used in oil and gas industry. Electrolysis and nickel boron and nickel plating of the one coating will be developed. You see the nickel boron, nickel phosphorus one, NiD, nickel boron and nickel plating, whatever phosphorus samples of this I'm showing here. The two I'm going to be phosphorus. So in this case, how the methodology, the samples have been coated with different types of chemicals, what kind of chemicals under the wet condition and dry condition, that under monitoring of weight losses of corrosion. So if it is applied with the coated, so how it could be after 8 weeks I tested it, how the weight will be losses. With the temperature less than 100 degrees centigrade, the nickel boron. You see my flowchart sample preparation in boron coating and nickel chloride, sodium, and then trisodium. So finally, enter all the samples. The sample experimentation. You see the experimentation, how we could be the one. Glass beaker, we can do the oil bath, the hot plate beaker, and based on the temperatures, we have to do the pH. So after that, oil bath, just give the results and stations. So the one 8 weeks of nickel chloride and boron hydride oxide will be carried out. You see the type of coating and weight loss 0.09 grams. And similarly, 7 weeks, after 7 weeks, after 8 weeks. So you see the weight loss here, the corrosion 0.4, 0.9. So 0.009, but 0.04 here, 7 weeks, and after 1 more week, it's lost. So corrosion types here, initial, final weight. Initial weight is like this, final weight is like this. Weight loss is 0.04 with the corrosion rate is 1.03. The graph one. And coating thickness. I'm just giving the coating thicknesses. So with a different kind of materials with the coating thickness. For my conclusion is the coated samples were tested for 8 weeks. After carry out the corrosion test with nanocoating. Significant protection of the samples, water and oil bath parameters were designed to fabricate to carry out the testing. Coatings. Corrosion rate and quality of the coatings were investigated with different types of coatings and phosphorus, different nano additives such as nano AL2O3, nano sodium. So CTAP and reported to the coating level. So this is my references and how to be follow this one. So what's my presentation? For
Unfortunately, if you have any doubts, you can ask now. Okay. Thank you, sir. Thank you for your nice presentation.
Thank you. Can I stop
Okay,
sharing my PPT?
Sir?
Can I stop my sharing the PPT?
Sir?
Any queries, sir? Questions on that?
Sir, shall I present my screen, sir?
Hello.
The voice is not audible. Actually, it was a nice presentation.
Okay, thank you. Thank you very much.
Okay, sir. Thanks for presenting your paper in our.
See any questions from that audience? So I'm waiting for the questions, or just I can close.
I think we can close it.
So shall I sign? Shall I? Shall I sign out, sir?
Yes, sir, you can sign it. Next participant is Gopati from Banari. Gopati. You are not connecting your audio.
Sir, yes, sir.
Okay, sir, you can start your question.
Yes, sir. The screen is visible, sir.
It is visible, sir. You can start your question.
Yeah, sir. Our topic name is performance analysis of PVT evaporator with parallel profile using salt hydrate as PCM, sir. Next is aim and objective of our project is reduce the temperature of solar panel and increase the efficiency of our solar panel, sir. Objectives to decrease the photovoltaic cell temperature, sir. Increase electrical efficiency of PV panel and decreasing PVT cell temperature, sir. Next thing is scope of our project. Overheating can be reduced the reduce the current efficiency, sir. So we can be decrease the temperature of solar panels, sir. It has been give more efficiency, sir. Using PCM and aluminum pipes, sir. Next thing is the need of our current study, sir. In future, we can be use most of them PV panels. So it has been increasing the temperature, reducing efficiency, sir. So we can be take our project is reducing a temperature of PV panels, sir, and increasing the current, sir. This is the need for current study, sir. Next one is the feasibility of the project, sir. Availability of resource and our renewable and HVAC lab. We can be use a lab to make our project, sir. In summer season, will assist achieving a better result, sir. Previous research we method show external factors reacting on the efficiency of photovoltaic panel cannot be controlled, and this technique of reducing from heat for photovoltaic panels. Using a phase change material to is simplified and cost efficiency way, sir, which is also environmentally friendly, sir. Cannot be create not pollution, sir. It focus on the internal factors such as PV surface temperatures. These are the feasible analysis of our project, sir. Next one is the proposed methodology, sir. First of all, we identify a problem. After we can be select a material for our project, and next one is purchasing of material for our project. Next one is we do a fabrication. we can be used experimental setup and without cooling, sir. We can be first using a normal panel. We can after we can be use PCM and aluminum to get a result, sir. Next one is result and discussion, and final one is conclusion, sir. These are the proposed methodology of our project, sir. Next one is a novelty of our project, sir. We can be use a parallel type pattern for a parallel type for water flow, sir, in our solar panel, sir. Next one is material. Material we can be use aluminum pipe of water conclusion. Since it's cost, we can be use a copper, but it can be cost is high, sir. So we can be use the aluminum pipe, sir. Next one is flow rate. We can be give you a different type of flow rate, sir. These are our novelty of project, sir. This is a choice of component and the equipment for fabrication, sir. Next one is this is a 260 watt PV panel, sir. Next one is yes, sorry, sir. So visible, sir. Sir, it's visible, sir.
Yeah, it is visible.
Yeah, okay, sir. We can be use 260 watt PV panel and half-inch aluminum pipe and thermal paste 1.5 inch aluminum pipe, and next one is clamp belt and current and voltage sensor and data logger and aluminum sheet, sir. These are we can be used of our project, sir. And this is the design of our project, sir. Next, first one is PV panel. After second layer is thermal grease. Next one is observer, and the next one is aluminum tube, and next one is PCM. Next one is insulation, sir. Next one is basic. This is a experiment setup, sir. This is a simple experimental setup of a project, sir. This is a reading of our project, sir. This is a day one. This is a solar radiation that particular day, and the next one is a wind speed of our particular day using a sensor, sir. Next one is a humidity, sir, of our day 2, sir. This is a air temperature of particular day, sir. This is a final result of our project, sir. This is a time, temperature, relative humidity of our project has been drawn in our graph, sir. This is a time electricity efficiency of PV panel and has been drawn in our other graph, sir. This is a temperature, time and temperature of PV panel and time has been drawn on other figure 3 graphs, sir. Next thing is figure 4 can be used for time, temperature, left corner, sir. Left corner of a PV panel, sir. And figure 5 is been time and temperature is a middle point of our PV panel, sir, has been drawn in our graph, sir. And this figure 6 has been water flow rate and the electric efficiency of our panel for PV panel, sir, has been drawn in our graph, sir. Figure 7 has been water flow rate, which is percentage of water temperature top midpoint of our PV panel has been drawn in our graph, sir. And figure 8 has been water flow rate versus and percentage of temperature left corner, sir, in our PV panel, sir. And these are our reference of our project, sir. That's all, sir.
Thanks for the
Yeah, okay, sir.
from audience. Any questions from audience?
Sir, shall I left my meeting, sir?
I have a few questions.
Yes, sir.
What kind of materials you used for that is PCM phase change material and for insulation?
Salt hydrate, sir.
What?
Salt hydrate, sir. We can be used for paste type of salt hydrate, sir. PCM type, sir.
For insulation? Okay, okay.
Yeah, okay, sir. Thank you, sir.
Next participant is Mr. Jagadish from Panari. Jagadish. Okay, so okay, you can start your presentation. You can start your presentation.
Okay, sir.
Mr. Jagdish, your voice is breaking. Mr. Jagdish, actually your voice is not like.
To use 3D elliptical hyperbolic concentrator for medium heat up.
கொஞ்சம் அமைதியா
For medium heat appliance, by using it, it will produce heat energy for desalination of salt water. This is the literature survey we studied, sir. Scope of the project. Water separation from saline water is complex due to excess presence of saline and other components which has to be treated with solar energy that meet lot of study. Design and analysis of elliptical hyperbolic concentrator. CO2 coating a low cost. It can reach extremely medium temperature in very short time with higher efficiency. Elliptical curve family concentrator are used in evaporating system, and water deforms much faster in the system than other shape of the concentrator like rectangle and circular structure. This is a need for the current study due to scarcity of
Your slide is not.
due to scarcity of need of current study due to scarcity of both energy and water crisis, in need of use alternative renewable energy source such as solar and wind energy has gained lot of moment in many developing countries. The research and development activities in solar energy is vital, and the water production from saline water is tedious due to continuous need of evaporation heat addition that we focus. Feasibility analysis. In order to fetch the solar radiation effectively in the solar collector, the work work director to change the surface property for enhance better reflectivity. With the help of this article, the relevant coating and material replaced will be changed accordingly for getting good performance. Experimental setup and testing methods are feasible for this work. This is the components that we used. Mycel copper tube, titanium dioxide, PCM, phase changing material, thermal 62 oil, and thermal pump. So this is the design. This is a novelty of the project. We use elliptical hyperbolic concentrator rather than use of circular or rectangular shape for better concentration of heat energy. We use thermal 62 oil in order to produce heat at the inlet of the water system. We also use PCM at the receiver port in order to maintain heat energy. We use a copper tube coil binding at a trapezoid shape receiver for circulating thermal 62 oil. So this is a result and discussion. Oil is used instead of water because after the evaporation of water vapor from salt water, salt remains on the copper tube, so oil is used. PCM is used in order to maintain the temperature constantly during cloud block out the sun for a time. Elliptical hyperbolic concentrator in the ratio 5:1. So this is a reference. Thank you, sir.
Thanks for the presentation. During the presentation, the slide was not moving. It shows that the aim and objectives were present. Okay. Thanks.
So can I share my screen, sir?
No need. Stop your share. Next participant from PSL set. Yes, let me begin.
Hello? So is it visible?
It is visible, ma'am. You can start it.
So myself, me, I'm a research scholar. I'm doing a research under the supervision of Dr. Radhika Ma'am, Professor of Department of ECE, PSM College of Engineering and Technology, Tirunelveli. My project, my heading title is Effective Segmentation Techniques for Tomato Plant Leaf Disease Detection. Tomato is a large consumable vegetable. Production suffers in diseases under various circumstances. The fast spreading nature of disease makes it worse. So the early detection is necessary in order to prevent the plant from damage and to increase the production rate. The diseases can be identified with the help of the plant leaf images. There are so many types of plant leaf images. I'm going to concentrate on mosaic as well as the curl virus, and I'm going to identify the healthy state of that tomato images. These are the sample images I have taken. First image is the that comes under the curl virus affected image. The second one is the mosaic virus affected, and the third one is the healthy image. The curl virus, by seeing the image itself, it is observed that yellow color between the veins. And in the case of mosaic virus, there is a molting appearance with alternate yellow and green appearance. In healthy image, we cannot able to identify any signs at all. So for this, I'm going to use four algorithms. Mr. Kapoor showing second one is a superpixel based persistent instruction algorithm. partial thresholding, and finally hexacycle color conversion. For the segmentation of curl and mosaic virus affected area, I'm going to apply the copper thresholding. It's an entropy-based thresholding method. Here, the threshold is selected based on the maximization of the overall entropy from the histogram information. The overall entropy that represents the brighter region. In the tomato leaf, the yellow region is related to that bright region. So I can able to segment those brighter regions which is affected by both curl as well as the mosaic virus. This is the result I have obtained after the copper thresholding. So from that segmented results, I can able to analyze whether it is a curl virus or it is a mosaic virus. For the segmentation and identification of the healthy image, I'm going to use hexacycle color conversion as well as the optic thresholding. The hexacycle color conversion to extract from that, I am using the eye channel information to give the intensity value of RGB component. So after also thresholding that intensity component, for a healthy image, I'm able to get a uniform foreground. But in case of the unhealthy images, it is impossible to get a uniform foreground. This is a segmented result of the 3 cases. In the healthy case, I'm able to get a uniform foreground. But in case of the curl virus as well as the mosaic virus affected area, it is not possible. So in order to ensure the segmentation as well as identification of the healthy image, I'm going to compare the result of the previous one with the supervised to pixel-based fast-processing image clustering algorithm. It initially computes the histogram of the color image and then computes the superpixel image by grouping the similar pixels by replacing with its mean value. And after that, it computes the histogram of the superpixel region, and from the histogram of the superpixel region, the fast-processing image clustering algorithm is performed. And I'm designed to design an algorithm to cluster 2 things. One is with the foreground, and another one is with the background. And after applying the optic thresholding, the foreground region is segmented. So this is the result for a healthy image as well as a curl image or mosaic. Whatever the image is, the cluster, the foreground as well as the background image. So after segmenting this one, I'm going to compare the result with the previous one, and I diagnose whether it is a healthy image or unhealthy image. And coming to the conclusions in the method, and by using overall Gaussian method algorithm, and I'm able to segment and analyze the yellow region related to curl as well as the mosaic virus, and able to diagnose the state of healthiness. And have tested it, those things over 100 images of each category in plant village database images. This can be extended by using a classifier at the identification page. And these are my references, and thank you for listening.
Thank you for the presentation, ma'am.
Sir, can I present, sir?
Sir?
Hello? Can you hear me?
Sir?
Ma'am? Ma'am? Can you hear me?
Yes, sir. Yes, sir.
Okay, ma'am. So my presentation is good for. Okay, you can leave now, ma'am.
Okay, sir. Okay, sir.
The next participant, Kiran Raj.
Sir, my screen is visible, sir. Am I audible, sir?
Yes, sir. Yes, sir. Your screen is visible. You are audible. You can start your presentation.
Thank you, sir.
Okay. Okay.
Sir, our project is expanded on comparative study on the optical properties of parabolic solar cooker with the surface coated aluminum and glasses, sir. Our teammates are Parimala Sundaram and Vishnu Prasad. Our guide name is Prakash KB, and Assemblers of Mechanical Engineering of Technology, sir. And this is our work plan. We have already completed the literature survey and conduct the experiment testing and fabrication work and CAD designing, modeling and structure works and pattern filling also. These are our work plans, sir. And our contribution work, I'm working in design analysis. project and fabrication work. Parimala Sundaram is working in literacy survey and material choosing and material purchasing, and Viswanathan are reflector choosing and purchasing and welding work also, sir. And this is a so object of the work is to design the parabolic solar cooker with the uses a parabolic shaped reflector in a direct sunlight to small area in order to generate the heat for the cooking, sir. The device is able to reach the high temperature at 350 degrees Celsius also, sir. And these are literature survey. We there's a lot of literatures. Then we refer a lot of review on that, and we have implement in our project, and we have get up the next generations like Arduino programming also in our project, sir. And this is the scope of the project. Design analyze the parabolic solar cooker and with the 3 reflectors referred like optical and aluminum sheet and titanium oxide coating, sir. They can reach the extreme high temperatures in a very short time with the high efficiency. The cookers are like the conversion of ones, like, sir. And need of the current is we have replaced that some normal cooking, and we have to scale the fuel and the world. So they factors only pose environmental risk, but also lead the rapid deformation and global warming depends on the natural resources. The renewable energy is available if it can be stored and reduce the demand of the fossil fuels. It absorbs the sunlight, store the energy from the PCM interfaces, and store the energy through the solar cooker is used to cook for the cook food, sir. And feasibility analysis with the reference to the previous articles, then he report the PCM based energy storage is used to reduce the thermal efficiency and fluctuation while variations are seen and collected in the way of regulated in the heat supply and cooking matters. The PCM we have used some wax and wax, and mostly of the we have used the PCM in wax, and this is our proposed methodology, literature survey and problem identification, design and fabrication testing and result and pattern and paper presentations also, sir. This is our properties and components: power screen, parabolic dish, motor stacking controller, testing, and pherometer. Pherometer using for analyze the temperatures of reflector, the ring connector and structure glass and galvanized iron sheets also, sir. This is our design and solar cooker parts. This is the reflector parts, and this is the base system, and this is the assembly of reflector. This is the CAD model of reflector. This is the diamonds of base and reflector, sir. And we have using some calculation. We have find the local constants ratio and interfact factor, and collected them efficiency and optical efficiency. Because we have analyzed some temperatures in using this calculation, sir. This is our project model in solar cooker, and this is our parameters: time, flow rate, and solar intensity, water temperatures, water outlet temperatures, and observer plate temperatures, and glass plate temperatures. This is our parameters, sir. And we have calculation some performance, some reflection ratio using this solar intensity and pherometer. These are all our performance calculations, sir. And we have used ANSYS for time variations of receiver plate temperature at the different time steps, sir. And this is the temperature variation, sir. Different between the this is the collector variation. This is the receiver variation of temperature, sir. This is the DNMA, the higher radiation level is observed with the collector. We have given some aptitude, longitude and latitude data in given the Agri University. They are given for higher radiation level levels. We have get from Agri University Coimbatore. This is the temperature received the receiver without storage. I mean, we have before PCM. This is our temperature variations of project solar cookers, and this is our reflector. This is the various reflectors. Some this is the aluminum coating. This is the opticals. This is ANSYS studies of fluence after and even absorption to get the absorption on any material little domain when the compared to the reflectance due to the thermal inertia with the camp balanced by the right conjunction and heat of the receiver selecting the right coating, sir. We have using titanium oxide coating also, sir, for more fluctuation. This is our receiver static temperature pattern, using ANSYS software, sir. Nowadays, in the current era, we are very much depends on the solar energy because energy crisis, so that cooking energy with the higher efficiency of focus in the work. And paraffin was high grade and piece of material, used the whole lot of heat and reduced thermal fluctuation. And the tracking system uses the track and sun presence during the daytime. In case the receive side, the shape factor improved with the turn neck and receiver, that the surface focus on the collector at maximum. So, we have using 3 reflectors. In previous in solar cooker, they are using only one reflector, but we have the various type of reflector for the more efficiency purpose. That's a novelty of project, sir. And this is our reference. And thank you, sir. Thank you so much.
Thank you for your nice presentation and wonderful work, Kiran Raj. Thank you.
Thank you.
Actually, I have some doubts on it.
Yes,
you are
sir.
using, I think parabolic, right?
Yes, sir.
Why you are choose this type of?
Because already they go to the round shape and another type shape. They are using already many shapes, like circle shape and square shapes also. They are using solar cookers. Box shape solar cookers also is there, sir. The parabolic is the is novelty of our project, sir. We have more reflection ratio in parabolic shapes, sir. That's why we can choose for parabolic shape.
Okay. Are you? I think you are using applying some coating material on it. I think so, right?
Yes, we have using reflectors, sir. 3 reflector, optical and aluminum sheet and titanium oxide coating, sir.
For coating and all, what technology you are using?
We have got the spray type, sir. The titanium oxide is the some powder form, sir. We have convert the some spray type coating, sir. We have spray on our aluminum sheet, then we gather that, sir.
It is durable, right? I don't, maybe you have to go with some other, strong techniques. Okay, right, but it's good.
Yes, currently we are using on aluminum and optical, sir. In future, we have using for titanium oxide, sir.
Oh, I see. Good. Another one is, what's the cost of this solar cooker? If it is, commercially, it's a feasible one or not?
Yes, sir. We have already done it in already have. Sorry, sir.
Yeah, I have seen that right now. That's why I'm asking you.
Yes, sir. We have some. Yes, sir. We have a lot of funds on that, sir. But in implement that, we have realized that the cost and estimation. That's why we have the in up to other making. We have reduced some cost for for testing, sir.
My simple question is, right now we have another conventional solar cooker is there, right?
Yes, sir.
In your
yes, sir.
home, you are using some other conventional cooker is there.
Yes, sir. Yes,
right?
Sir.
While you are going for a commercialization, right? The cost of the cooker, it will be feasible one, right? Then only the people will purchase.
Yes, sir.
Can you hear? Yeah. That's right. Just I'm asking you, right? What's the range,
Yes,
right?
yes, sir. Our project
conclusion.
conclusion. Yes, our project concludes we are using renewable energy for upcoming generations, sir. That's why we have using the setup.
Okay. But this is, it's purely for research purpose alone, right?
Yes, sir. This is for research purpose, and we have implement on working for practical life also, sir, in future.
Okay. It's go. It's really great to see your pictures and everything. Wish you all the very best and do well. Thank you. Thank you for your
so much, sir.
Presentation in Smart 22. Okay. Yeah.
Thank you, sir. Thank you so much.
Thanks a lot. Yeah, convey my wishes to our teammates also. Thank you.
So thank you, sir. Thank you so much.
Yeah,
So can I stop my session?
Yeah, it's okay. Anybody have any doubts, you can ask them, and otherwise you can stop your section. You can quit the session. The participants, anybody have doubts, you can go with that. Otherwise, you can leave.
Okay, you can leave the. You can stop your presentation. The
Thank you,
next
sir.
participant, Molly Bharati. Okay, sir. Okay, sir. The next participant, Molly Bharati from Pannariaman College. Are you online?
So can I leave the meeting, sir?
You can leave, sir.
Thank you, sir.
Okay, sir.
Sir, can I present?
Bhubadi from Pannariaman College, sir.
Yes, sir.
Okay, sir. You can present.
Says my screen visible?
Yes, sir. It's visible. You can start your presentation.
Good afternoon, sir. I'm Bhubadi from Banana Crop Technology. I'm doing my final year in Department of Mechanical Engineering. I'm doing a project in the title of Experimental Study on Dual Source Solar Dryer with a Passive Heat Method, and with my friends Divin and Dayanidhi. Our aim of our project is to develop a solar dryer working 24/7, working in daytime and nighttime, and we have to we are comparing a performance of solar dryer with using PCM and without using PCM. And our scope of a project is to the thermal energy stored in one which we can store a most efficient. We are finding a most efficient way to store solar energy for a heater for heating air by it's called by collecting from a solar radiator. We use paste-in material to improve the latent heat storage and efficiency of a solar dryer. Need of current study. While there is a lot of affordable solar dryer which works in a daytime, there are not many solar dryer which work in night. So we are planning to we have made a solar dryer which works on in both day and night. So we use we use an PCM to store an electric to store energy, to store heat energy, and when there is a fluctuation, we will it will be supplied the heat to the solar dryer. Proposed methodology. First, we have studied a literature survey and we identify the problem. Then material selection and purchasing and the fabrication of dual source then we fabricated a solar dryer. Then we are taking a testers with using a PCM and without using a PCM. Then result and discussion and conclusion. Choose of components: compressor, condenser, evaporator, temperature sensor of fan, copper tube, aluminum, paraffin wax, and sheet metal we are using in our project. This is our design of our project. This is our outcome of our project. We are using a collector which collects a solar radiation and stores an heat energy to a paraffin wax. When there is a fluctuation of heat, we supply. When there is a fluctuation of heat, we supply a hot air. Releases from a paraffin wax. Through that, we are drying solar ray. Oh, yes. I think that's all. Then this The first image is an condense AC outdoors. Through that, when there is an when we used to store in a paraffin wax, it will be in the evening time. It will be efficient for around 2 hours. After that, we in night we can't able to get a heat from a storage. So we use AC outdoor condenser, and we supply the heat through in a copper tube, and we heat the paraffin wax. Then through that also we release the heat, and we dry the products. So these are some reference of our products. So thank you.
Okay, sir, it's a nice presentation. If the participant have any doubt, you can ask him. Okay. Monitor, are you present here? Hi, you can leave. You can leave. Monitor, are you present here or not? Okay. If anybody else want to present, you can present now.
Okay, so myself, Raja Durkamani, shall I present now? From Dr.
Okay, you can present. Please tell me your ID number.
M1071, sir.
1071. Okay, ma'am. You can present.
Okay, ma'am. Okay. Sir, whether the screen is visible?
Yeah, it's visible. You can present.
Good afternoon to one and all present here. Myself, Raja Durkamani, pursuing Master of Engineering and Department of EEE at Dr. Mahalingam College of Engineering and Technology, Pollachi. My presentation is about power consumption and delay trade-off based effective workload allocation in fog device. Okay, first of all, IoT. IoT is Internet of Things, which describes physical objects with sensors, processing ability, software, and other technologies that connect and exchange data with other devices and systems over the Internet or other communication networks. Due to the rapid development of IoT, number of peripheral devices were connected and produced large voluminous data. So the transmission of data increased to the cloud, which not only possessed a heavy burden on communication bandwidth, but also resulted in unbearable transmission latency and degraded service to end users. This also creates all the requests are sent to the main server. Traffic overhead is increased and causes delay, which cannot be tolerated in delay sensitive applications. By employing when we employ inappropriate scheduling, it leads to high power consumption in fog device. So there is a need for proper scheduling and my objective is to allocate effective workload by analyzing power consumption and delay by various scheduling algorithms. Fog computing. The term fog computing is also called as fogging or fog networking. Is coined by Cisco in 2012. It describes a decentralized computing structure between cloud and device. It uses each device to carry out a substantial amount of computation, storage, and communication. So this flexible structure enables user to place resources, including applications, and helps in a lot to enhance the performances. It is not a replacement of cloud computing. Fog computing is an extension of cloud computing that consists of multiple edge nodes directly connected to the edge devices, or getting as close to the source of information as possible. Hence, fog computing is a promising emerging paradigm. This is the fog cloud framework referred from Deng et al. The overall architecture has been divided into 4 parts, 4 subsystems. First is LAN, next is fog computing subsystem, and third is WAN, and fourth is cloud computing subsystem. LAN subsystem is also called as front-end portals, which acts as a user interface. It receives the service request from end users. After receiving the request, they are separately given as input to a set of fog devices through LAN. Then fog computing subsystem is a decentralized computing infrastructure in which data where compute as well as applications are located somewhere between the data source and the cloud. It processes some of the requests which are most delay sensitive and forward other requests not delay sensitive to cloud. The unprocessed requests are dispatched from each fog device to each cloud server through WAN. In cloud computing subsystem, there are a set of cloud servers, each of which hosts a number of homogeneous computing machines. Power consumption and delay analysis in fog device. The main power consumption. The main idea behind fog computing is to process data, so much data as possible. So there is need for effective scheduling. In usage of inappropriate scheduling makes power consumption increment. So therefore, a proper workload allocation can minimize a power consumption of device in fog system and overall consumption of the network. This equation is used for modeling the power consumption and in fog device. Similarly, delay for delay with a huge volume and ever increasing service request, power also increased with the since power increased, delay also increased. So it is important and desirable to consider delay in cloud for computing system. The reason is that unbearable response latency leads to revenue losses, since users will subscribe to other vendors with better service. This equation is used for analyzing delay in fog devices. And power delay trade-off. Trade-off means where when we choose one course of action over the another, it is called trade-off. Here we considered power and delay relative changes with respect to the waiting factor and service request. And the equation is used to analyze the power delay trade-off analysis in fog device. Workload. Workload is the percentage of work required by the processor to execute the task. In this project, 3 scheduling algorithms were used, and its workload were analyzed. Namely, it's shortest job first scheduling, first come first served, and round robin. For the equation formula for calculating workload is process the time and elapsed the time. And the next is scheduling. Scheduling is the main challenge in fog computing because scheduling plays an important role in managing resources in fog computing. Resource constraint and latency sensitive nature of fog applications make resource management one of the key challenge in fog computing. Therefore, the decision of resource allocation and job scheduling is of greater importance, and so there is a need for scheduling algorithm which should minimize the latency along with optimal power consumption and delay. First, SJF scheduling, it is also called as shortest process next. The process with the shortest processing time is selected for the execution among the available process in the ready queue. So the shortest process will jump over to the longer job. And first come first served scheduling is also known as first in first out or first come first choice. It schedules the jobs according to their arrival time, whereas in round robin scheduling, it is a preemptive scheduling. Every process gets executed in a cyclic way, and it is mainly depend on the time slice, which is known as a time quantum. This is the result when we considered, if we consider 5 number of nodes, if we employed SJF, then it consume nearly 15% of workload, but in first come first served, it consume higher, similarly nearly 45 percentage. And when employed round robin, it also in approximately near 15% of workload. For that 30% of workload, SJF consume less power than first come first served and round robin. And also in delay, when we consider for the 40% of workload, SJF consume nearly less than 0.1 seconds of delay, but wherein first come first served and round robin, it is above 0.12 seconds. And also in power delay trade-off, in number of requests increased, SJF is consume less amount of energy, but as first come first served and round robin takes maximum energy than SJF. And this is the comparison table made from the result. And the conclusion is that if we employed SJF, it results in 18% and 23% lesser workload than first come first served and round robin. And it also results in low power and low delay and low power delay trade-off with first come first served and round robin. These are the references. Thank you for giving me this opportunity. Thank you. Sir.
Thank you. It's a nice presentation. I want to know about the detailed view of the fog device. What is meant by the fog device?
I could not hear you, sir.
Can you hear me?
Yes, sir.
Okay. Let me shortly tell about what is fog device.
Fog device is nothing but, sir, the device comprising the fog infrastructure, which are called fog nodes. It having the capabilities like processing and storing the data.
Okay, ma'am. Any other participant want to ask questions? If anyone have queries, you can ask to. Okay, ma'am. You can leave now. Okay. If anyone else want to present.
Good morning, sir. Our project is extreme.
Okay. Please tell me your project ID number, please.
1097.
1097. Okay, sir, you can start your presentation. Please complete it within 10 minutes. Okay, sir?
Yeah, sure.
Okay.
Good afternoon, sir. Our project is an experimental study on solar photovoltaic panel using HS29 and HS34 as phase change material. Our group members are Vishnu Sangha, Valinagam, Mani Balaji sir, Department of Mechanical Engineering from the Bannari Amman Institute of Technology. Our aim is aim and objective to construct and analyze the performance, construct and analyze the performance of a photovoltaic panel using HS29 and 34. Main objective of our project is to design the system to increase the electrical efficiency of solar cell by using cooling the cells and absorbing heat generation by the cells and during the day. Our work done was studying the cooling system technologies, purchasing the required materials, experimental setup using appropriate methods, tools and equipments, setup of PV panel in terrace, attaching the cooling system, integrating the Arduino code in a sensor so we can measure and record the temperature, experiment outcome in measuring the surface temperature without cooling setup, with a cooling setup, comparing the both results, detection of improvement efficiency. Contribution to the work, purchasing of material, literature survey, design and fabrication. Scope of the project, electricity is produced by the solar cell is clean and silent because they do not need any fuel than sunrise. A PV system do not release any harmful air or water pollution into environment, depreciate natural resources or endangers or human health. Photovoltaic system or quick and visual. Solar energy is locally available renewable energy resource, does not need any import from other regions of the country across the world. This reduction environment associated with the transportation, also the reduce the dependency of the import of oil, unlike fuels that mined and harvested. When you use solar energy, produce the electricity, do not depreciate or alternative resources. Feasibility in this project, we using HS29 and HS34 as a phase change material for the cooling the process instead of using the para-vaccine. Due to para-vaccine, it could not withstand high temperature, and the cost of the para-vaccine is high compared to HS29 and 34. Literature survey, we have made it to a need for current study. Renewable energy is a crucial to reduce the air pollution, improves the health and well-being, and provide the affordable energy worldwide. This paper, from the International Renewable Energy, they telling that and the future will be in the renewable energy. Proposed methodology, identification of problem, literature survey, selection of the component, fabrication and assembling the component, research and discussion. Novelty of the project, a PV panel center is in the pot. The center part is overheated due to inclination of position of panel. It affects the efficiency, so that we use the PCM in order to control the such temperature. Research and discussion. Without PCM, we got the panel temperature is 75 degree. With the PCM, we got a temperature is 38 degrees Celsius. Efficiency is increased in 9.2 from 16%. References we have made it to, sir. Thank you, sir. Thank you, sir.
Okay, sir. It's a nice presentation.
Okay.
Waiting for a few minutes. The next session will be start at about 2 p.m. You can leave the session. The
Okay,
person who
sir.
want to present next, please text on the chat to get the first preference.
Can we leave, sir?
You can use it was my presentation. Thank for the presentation. Okay, the after the in the afternoon section, the first participant is Subitra. The badge number is ID number is 1081, and the next one is Vishnu Sankar. Its number is 1097. Okay. You can leave now and join correct shortly. Hello everyone. Sorry for the delay. Good afternoon.
Good afternoon, sir.
Okay. Suprita.
Yeah, yes, sir. Can we start, sir?
Hi. Okay, you can start.
Thank you, sir.
Okay.
So, good afternoon, Ronald here. I am Suprita and my teammates are Geeta and Srimati. We are here to explain our project. Our title of our project is Quick Witter Shielding System for Upscum Laborers using IoT with sensors. The main motto of our project is to make some safety precautions for the sewage workers to enhance their work lifestyle in a better and efficient way. Then objective. In our country, the work of sewage maintenance is not quite easy work. It has many risk and tough works. So our objective is to develop a device which would monitor the health condition of the sewage workers. The sensors present in our project will monitor the body conditions at various scenarios. The information will be sent through GSM technology. And then introduction. Sewage workers die every year due to the lack of facilities to clean the sewage. There are no design manuals for the laborers to work regularly. So it is necessary to prevent the sewage workers from toxic gases and to keep them healthy. And then existing system. There is a device which will monitor the pulse rate of the workers. The methane, turbidity, and the oxygen sensors provides alert to workers and the exterior unit. The problem we found in the existing system is the workers are led to fire or explosion, oxygen depletion, inhaling of toxic gases, and fumes inside the sewer. In our project, we are trying to overcome those problems for the sewage workers to enhance their work lifestyle. And then flowchart. This is a flowchart of our entire project. Initially, we need to set up the hardware power supply. The sensors such as toxic gas sensor, ultrasonic sensor, and temperature sensor will start to sense the values of the atmosphere, and these values will be passed to the Arduino board as the input. The LCD and the website will display the detected values. If in case the sensor exceeds the limit or the panic button is pressed, the vibrator will be on, or else it will continue its analyzing. The following slides will be explained by Geeta.
Good afternoon, sir. This is a finding in an existing system. The drawbacks of the existing system will be rectified by our proposed model. Here, we are trying to replace some old component and to fix some new components for the better performance. And this is our mode of our project. And then next, proposed solutions. Our main component is the Arduino microcontroller Atmega 328. In this Arduino, we are going to connect toxic gas sensors, panic button, temperature sensors, and ultrasonic sensor. This all information will send it the LCD displays. And this is our proposed system solutions. And then next, methodology of our project. First, this is our project main. We have to connect that Arduino Atmega 328. Atmega 328. In this Atmega 328, we have to connect toxic gases. This toxic gases to predict toxic gas sensors such as carbon monoxide, hydrogen sulfate. These kind of gases, it will be predicted toxic gas sensors, and also temperature sensors. The temperature sensors, they have to detect that temperature level of the surroundings, and ultrasonic sensors. The ultrasonic sensor to predict sewage level on and to predict whether any solid particle nearest to the sewage workers. And the panic button, they have to feel the sewage workers any bad. At that time they have to press that panic button. Suddenly that information will be displayed on LCD display, and then they have to come out of that sewage waters. And then next slide will be explained by our teammates Srimati.
Now we can see the literature survey of our project. From these papers, we have took the idea to our project and explore it. The first paper is a review paper on I2C communication protocol. From this paper, we have taken the idea to communicate with the laborers. And the next paper is the wireless monitoring system for pulse oximetry sensor. From this paper, we have taken the idea to detect the person as a pulse oximetric sensor by using pulse oximetric sensor. And the next paper is design and development of a heart rate measuring device using fingertip. From this paper, we have used as a temperature sensor. Then only we have to detect our heartbeat by using it, because our body temperature will rise and decrease based on our temperature. So only we have to detect the heartbeat rate of our body. The next paper is Code Blue and Ad Hoc Sensor Network Infrastructure for Emergency Medical Care. From this paper, we have to measure the person condition inside the drainage canal.
వాయిస్ ரொம்ப బ్రేక్ ஆகுது, கொஞ்சம் சிக்னல் அதிகமாக இருக்கும் பார்த்துக்கிட்டீங்களா?
Okay, sir. Next we can see the software requirement of our project. In our project, we have used as a embedded C as a programming language and Arduino IDE as a compiler. Next, we can see the hardware requirement of our project. The hardware requirements are Arduino UNO, power supply, basic gas sensor, ultrasonic gas sensor, LED display, buzzer or vibrator, temperature sensor, and panic button. Next. This is the sample result of our project. These are the some of the references we have taken.
Sample project, say the sample project. You said that this is sample project. I can't see the pictures. Can you show that again?
So these are the values as will be displayed on the LCD, sir. Hello.
Can you hear me?
Yes, sir. So these are the values which will be displayed on the website.
Ma'am, your slide is on the hardware requirement specification. In which slide you are presenting?
The slide is in, it is in page. Now it is visible, sir.
So now your slide is on the hardware requirement specification, but you are talking about somewhere else. Can you show the slide correctly?
Geeta, can you stop the share and share it again?
Now it is visible.
Yeah, it is visible now. Please go to the sample result slide. Sir, is it now visible now, sir?
Yes, it is visible.
So these are the values which will be displayed on the website, sir. It will be updated within every 10 seconds.
Okay.
Okay, sir. Thank you all.
Okay, ma'am. This is my presentation. I have a doubt. For temperature sensor, did you use the IR sensor? Infrared sensor. For using a temperature sensor, which type of temperature sensor did you use?
It is DH11, sir. DH11.
DH11. Okay. Okay, ma'am. It was a good presentation. Thank you for the presentation.
Thank you, sir. Thank you, sir.
Okay, ma'am. Okay, ma'am. The next person will be. You can leave now.
Okay, thank you, sir.
If anybody want to ask questions, you can ask. Otherwise, Vida, you can leave now. Okay. Okay, ma'am.
Thank you, sir.
You can leave now. Okay, ma'am. Okay. The next participant will be Vishnu Sankar. Paper ready in 1097. Okay, he is not present. Munir Selvan, who is that? Mr. Munir Selvan?
Yes, yes.
Yes, sir. May I know your paper ready number, please?
1119.
119.
1119.
Okay. Sir, from which college do you present?
VB College of Engineering.
VB College of Engineering. Okay, sir. You can present now.
Host. Sir, host ஆக்க முடியுமா?
Sir?
சார் என்ன ஹோஸ்ட் ஆக்க முடியுமா? அப்பதான் நான் ஷேர் பண்ண முடியும். ஸ்க்ரீன் ஷேர்.
இல்ல அப்படிலாம் இல்லை. நீ ஷேர் பண்ணலாமே.
ஷேர் பண்ணலாமா?
Yeah, you can share.
ஸ்க்ரீன் தெரியுதா சார்?
It is visible. You can start now.
Okay. Good afternoon to all. I am Munir Selvan, Assistant Professor, Triple Department from VB College of Engineering. Headed by Dr. P. Radhika, Professor, ECE, PSM College of Engineering. Our project title, Performance Evaluation of Current Extraction Techniques for Shunt Active Power Filter. I'm a PhD scholar. Based on my topic, we chose the title. Abstract of our project, a nonlinear low electrical devices has lead to distortion in the output sine waveform of source current and voltage. Okay, nowadays we have power electronics devices used in the all equipments. Okay, the power electronics devices generate a harmonics in a devices. That harmonics will create a distortion in the sine waves. So it will be eliminated by the shunt active power filter. It may lead the equipment to overheat. The power electronics devices are created by overheated by the equipment and sometimes cause damage due to the harmonics. In this paper, the shunt active power filter is used to improve the power quality of electrical network by mitigating the harmonics with the help of time domain and frequency domain control strategies. And here, the power quality based on THT values, the proposed work is simulated by MATLAB Simulink, and the results is satisfied the IEEE standard of power quality. The IEEE standard values are IEEE 519, for power quality systems. And what is shunt-active power filter? Before that, what is active filter? Active filter acting as a source, current source or voltage source. And here we can use shunt-active filter. Before that, we discussed about the series active and shunt and series combination or hybrid active filter. And here the best option for active filter, shunt-active power filter, because this is a current source inverter. The current source will be acting in the inverter session. Okay, act as a current source which produces a harmonics current having opposite phase than those harmonics produced by nonlinear loads. It opposes the normal source current. The source current will be delivered from the generator side, and the load side can create a nonlinear. The nonlinear load create a harmonics. That harmonics will be eliminated by the shunt-active power filter. The active power filter is connected is parallel with a nonlinear loads. So then only it is called as a shunt-active. It is parallel to the load circuit. And this is a basic circuit diagram for shunt-active power filter. And here we have a main source, the power system having a main source, and here the nonlinear loads. The nonlinear loads create a harmonics. That harmonics will be eliminated by the source, current source inverter. The current source inverter here we can act as active power filter. The active power filter have some of the elements. You can create a current. You can create a current. That is, current is opposed to the nonlinear load current. Okay, and here the nonlinear load current have some harmonics value. That harmonics value will be eliminated by the shunt-active power filter. So normally, a general mathematical relationship: the source current IS current, and the load current is IL. And here we can create a harmonics current IH. And here the data will be normally current. Kirchhoff's current law states that the sum of current entering is equal to sum of current leaving at the node junction point. And here this source current is a sum of current entering point, and the leaving point will be eliminated by the load current and the source current. By the way, we can eliminate the harmonics at the load current side. And what are the harmonic sources? The nonlinear loads, that is loads that draw a non-sinusoidal current from a sinusoidal voltage source. Some examples of harmonic producing loads are electric arc furnace, static VAR compensators, inverters, DC converters, switch mode power supplies, and AC or DC motor drives. So most of the compensation will be based on the power electronics devices. So those power electronics devices are created a harmonics in the circuit. And control algorithm in shunt-active power filter. Okay, we have a harmonics current extraction algorithm. The harmonic current extraction algorithm working with load current, and the load current will be a harmonic current. That harmonic current extracted by this harmonic current extraction algorithm. Okay, and then the extraction current will be controlled by the current control algorithm. The current control algorithm working with current source inverter or voltage source inverter. And next we can DC link voltage control algorithm. And the DC link voltage source will be changes with respect to the current values. That current values will be high or low with respect to the DC link voltage. But now our condition based on DC link voltages should be constant at the source side. Okay, you should maintain DC link voltage is a constant. And next one is the phase control algorithm. And here this opposing the current means, so negative phase will be created at the load side or power system side. Next, move on to the harmonics current extraction method. And the source is connected to the nonlinear load. The source current are flow through the line. The harmonics currents are extracted from the nonlinear loads. The source currents are delivered from the generating station, and here it will be received by the load. The load will be create a nonlinear load that will be created a harmonics current. That harmonics current will be sensed by the current extraction method. Okay, the harmonics currents are extracted by various algorithms. The algorithms are based on the time domain and frequency domain analysis. We can use time domain analysis, various methods we can use, and also frequency domain analysis also have a lot of methods. The proposed method is to use to extract the harmonious current from the load current by instantaneous real and reactive power theory and wavelet transform. Here the wavelet transform based on the frequency domain analysis and reactive power theory based on the time domain analysis. First, we can explain the harmonious extraction algorithm by time domain analysis, and various methods we can use. Filtering approach using the conventional low pass filter, normal LC filter or RLC filter. Okay. The instantaneous real and imaginary power PQ theory, that method will be used in our project work. And next one is instantaneous reactive and reactive current method, DQ method, or another one is nonlinear least square NLS elimination estimation method, and etc. We can use in the harmonious extraction method. And here we can use instantaneous real and imaginary power. That is PQ means real power and Q means imaginary power. Okay, so instantaneous real and imaginary power theory that will be discussed in the paper. And another one is the frequency domain analysis. And here the basic frequency domain analysis are FFT algorithm, DFT, wavelet transform, wavelet packet transform, and S transform, etc. And here we can use wavelet transform is a frequency domain analysis for current extraction method. Topology for real and or active or reactive power PQ theory method. And here we can use the three-phase supply, AC supplies, RYB. That RYB will be current source and also voltage source. Okay, so it will be differ by the reference values, voltage and the current. And it will be a three-phase supply and three terminals or three-dimensional waves. And here it will be converted into two-dimensional by using the PQ method. And it will be further converted into the another method for the PQ method, the 2 to 2. That is 2-phase to 2-phase, then 2-phase to 3-phase method by using the inversion of the coefficient values. Okay, what is that meaning here? Input is 3-phase supply and also output is also 3-phase supply. And here the current value is the reference current. Okay, the extracted current will be output of the circuit. Okay, before that here we can use the VDC values also. The VDC values are controlled by the PI controller, and VDC is the DC link voltage. The DC link voltage will be a constant at the source side. Okay, and it will be maintained by the controller circuit. And also the output of the controller, we can get PDC, that is a DC power output. The DC power output will be injected in the PQ theory algorithm for better result. And the mathematical relation for the PQ calculation. And next the voltage controller, that is a DC link voltage controller. The VDC should be maintained by PA controller. The current will be limited at the current limiter circuit. The reference current generated from the PQ theory algorithm, and it will be generated a gate pulse, and the gate pulse will be created by the or generated by the hysteresis current controller. This is the gate signal. That gate signal is fed to the voltage source or current source inverter. And next, frequency domain analysis, that is a wavelet transform. The wavelet transform is a mathematical tool that decomposes the signal into representation of that signal details and function of time. It will be separated by the signal with respect to the low pass or high pass pattern. The wavelet platform perform with the signal analysis when signal frequency varies over time. We can use this representation to characteristics, transient events, reduce noise, compress data, and perform many other operations. The main advantages of wavelet method over traditional Fourier methods are used for localized basic functions and the fast computation speed compared to the other methods. The types: continuous wavelet transform and discrete wavelet transform. And we have to use the discrete wavelet transform, and it will be used by the methods of multi-resolution analysis. And here the signal will be separated by the high pass and low pass filter, and it will be separated the signals, the low pass filter, another classification, high pass and low pass filter, and we can get a signal C1 of n is equal to summation of k of h of k to power k minus 2n into C of k. That values will be referred from the low pass or high pass filter, and here the high frequency signal will be getting from the input signal. And each value will be referred from the data. And here this is the proposed method for our project work. And here the AC source, and here the nonlinear loads, the extraction of the harmonics current from the nonlinear loads by using the PQ theory and also wavelet transform. And here the signal will be referred from the DC link voltage. The DC link voltage will be constant with respect to the current source or harmonic currents. The output of the DC link will be referred by the PI controller, and the signal will be referred from PI controller and also PQ theory. And this signal will generate a gate signal of this shunt active power filter. That is a current source inverter. And here current source or voltage source inverter. And here the hysteresis current controller we can use for generating a gate signal for the shunt active power filter. Assembling model without filter. And output of the filter circuit, without filter circuit, you can get a harmonic signals. And here the FFT values, that is the THT values at the filter side. Okay, without filter we can get the values of THT. And here we can use the simulating of with shunt active power filter. The output of the shunt active power filter. In conclusion, you can get the simulation is carried out by using the PQ theory. The THT values 4.7%. 4.7%. It will reduce from 25.86% from the data. And here the without filter we can get 25.86%. Before that we can get now we can get the PQ theory and the wavelet transform. We can use the 4.7% of THT value. Okay, the IEEE standard based on this less than 5%, it is acceptable values. So our project will be get 4.7%. That is reference. Sir.
Awesome. It's a
Okay,
nice
sir.
presentation. It's a nice presentation. I have said.
Thank you, sir.
Okay, sir. Okay, sir. If you don't have any doubts, so you can leave now.
Sir, shall I leave?
Listen, sir. You can leave
Sir.
now, sir.
Okay, sir. Thank you.
You can leave now. Okay, sir.